Okay, guys, let's get started. Welcome to Zero to Hero Security class. This is Piotr speaking, and this is meeting number 5. Let me share my whiteboard. Right, so that's the week 5, the 5th meeting. And today we're going to continue talking about the firepower. Specifically, we're going to focus on firepower features. I'm going to start with NAT config, just briefly, because that's something that we already covered in the ASA, and the NAT is basically exactly same, but the configuration is obviously different because we are using the Firepower Management Center to configure, but the resulting configuration gonna be the ASA commands that we know from the ASA lecture and topics that we already covered. Then I'm gonna briefly talk about the QoS. So this is also a feature taken from the ASA. And then very important one, I'm gonna cover pre-filter policy. I'm gonna talk about how you can bypass traffic. That might be very important for some of you, especially those of you who are keen on not sending some traffic through the firewall for some reason. For example, to not introduce additional delays. Voice traffic, some video, maybe multicasts, or just the big or huge flows like backups or something like that. So we're gonna use pre-filter policy, and I'm gonna talk about architecture a little bit more during this lesson. I think personally, I think this is one of the most important lessons, not only to cover pre-filter, but generally to cover everything related to the architecture and how the product is built. Okay, guys, in the chat, I see Frank said that audio is choppy. How do you get this? Okay, it's fine for Ed. Anybody? Yeah, so it looks like something on your side, Frank. If you can just leave the audio and rejoin. That may help. Okay. Right. Continuing on the agenda for today, then network discovery. Network discovery, quite important feature that that we need to discuss. We already talked about this a little bit. This is the ability of the product to find out what's on the network, what's on the host, what's on the server, and based on that information, we can build a host profiles to better know what's going on, and then later, based on what was discovered, we can tune up our IPS policy. So that's very important. Actually, the whole lecture is like it's like a one step-by-step deployment guide for you, right? If you are going to deploy a firepower in your network, this is usually the step-by-step that you're gonna take, right? You need to consider things like NAT, the basic access control policy that we talked about last week, the QoS, if obviously that might be optional for you, but that's something that you should consider. The pre-filter policy, what you're bypassing, what not, and then the very first thing that you need to do is the network discovery configuration, or network discovery policy, proper configuration, right? And then we can enable some additional features on that product. We have a full connectivity, our packets going through the device, and now we can add some security related features to the product to further extend our security capabilities. One of the most important ones is the security intelligence. I would like to talk about this, and maybe if time allows us today, we will be talking about AMP. It's another feature that we can enable. AMP and file policy Okay, cool. So let's move on. And actually, if it comes to the NAT config, we already covered that in ASA, so you should be familiar with all the terms, acronyms, and all that stuff around that. NAT on firepower. Right, so first thing is this feature, right, is ported from ASA code. Okay, so basically you can expect that everything that you configure will result in ASA commands, configuration commands for NAT. Okay. Second, you configure use FMC to configure NAT policy. Okay. Now the NAT policy, when you are trying to use it for the first time, it's going to ask you to choose what type of NAT policy you're going to configure. Is it a NAT policy for FTD, for firepower threat defense, or this is a NAT policy for the old legacy, let's call it, firepower software? Obviously, we're going to be using the net threat defense policy. So let me share my lab real quick so you're going to see what I'm talking about. Okay, that's my firepower. If I go to the devices and NAT, I configured that NAT last week. Yeah. Notice that I have a NAT policy configured called NAT, and the domain is a threat defense. When I click a new policy, I need to decide, okay, am I going to configure the old NAT, which is for old next generation IPS device, or the new threat defense? Remember, the threat defense is FTD, is the software on a device, on a sensor that is combined from two softwares, from the firepower and ASA together. Right? So this is the one that we're using, and this is the one that's going to be used in the future. Right? So nowadays, you shouldn't really consider using the old one. Right? So when I click here, I need to give it a name, like NAT, right? Something, then select the device, add to the policy, and save. That's going to create a policy like this, like I already done that last week. So let me edit that so you can see what are the rules. Remember, on the ASA we have three in the NAT policy we have three sections. Section 1, which is the manual NAT. section 2 auto NAT and section 3 manual NAT, but after auto. Let me actually show you. It's going to be easier if we do that this way. Let me go to the website. That was covered, I believe, in a second week. Let me share that. Okay, see, this is our drawings from second week of ASA, and we have a NAT. Right? We talked about NAT, PAT, different types of NAT, port address translation, issues with PAT, dynamic NAT, static NAT, all that stuff, right? And when it comes to NAT order of operations, we have a NAT table on the ASA, and there are 3 sections. Manual NAT, where all NAT commands entered in a global config mode are going to be. Section 2, which is auto NAT, everything that you configure under the object, like object network LAN, subnet 10.0.0.0, and then you say NAT something something. And this command and all that stuff is going into the section 2. And section 3 is again the manual NAT, but with a special keyword after -auto. So this is exactly the same thing, but we done that in a CLI. But if you take a look at Firepower, we also have those 3 sections. They have a little bit different names: NAT rules before, auto NAT rules, and NAT rules after. Okay. So if I click add rule here, right, I need to choose which or what NAT rule am I going to add. Is it a manual NAT or auto NAT? So object NAT or manual NAT, right? Remember, the manual NAT is useful when we need to translate source and destination at the same time, or if we need to specify a flow. Like for example, in a NAT exempt, if you want to exclude something from translation, we need to add a manual NAT entry to the table that is translating actually the same to the same for the source and destination, but also making the flow at the same time with this config. So that's the manual NAT, right? So, or auto NAT. If I select auto NAT, then I need to choose which type of NAT am I going to configure. Is it a static or dynamic? Remember the difference between static and dynamic? We talked about this as well. Where is this? Dynamic NAT versus static NAT. Right? Dynamic is when you are hiding behind the NAT or NATed IP address. So it's useful when for users going out to the internet. We don't need anybody from the internet to originate a traffic from the internet to the inside, right? We just going out and the returning packet will be automatically untranslated for us. But static is useful when we want to do NAT that is working both ways, right? So we don't need to have any packet first in order for a NAT to work both ways, because static NAT is always have a xlate in the NAT table, right? So in the xlate table actually. So that gives us ability to translate both ways, right? And if the internet or guys from the internet want to connect to the host in a DMZ, then this is possible because we have static NAT in a entry in a XLate table. So we are untranslating the destination, right? For our host in a DMZ going out to the internet for updates or DNS or something else, we are originating connection from here. Then this is going to be the static NAT. So depending on the direction or where the connection is originated from, or what site, then we are talking about destination NAT or static NAT. Sorry, source NAT. Okay, but this is the static NAT type. So remember, dynamic is useful when you want to hide, when you don't need to have an opposite side to originate the traffic or originate connection to you. So things like users going out to the internet or users to the extranet connections, like partner connections, the policy NAT. This is actually a dynamic. See, the source is dynamically translated from one IP to another IP. We are hiding behind this IP. Okay. So we need to understand the difference between static and dynamic. Right? And then depending on what we select here, we have some options that might be here or might not be here, depending on the ability of configurations. For example, if you choose dynamic, you don't have a original port selection because you cannot do the dynamic port translation in this case. It's only available for static. Right. So FMC to configure NAT policy 3. Resulting policy is a NAT table on the FTD. Right. So if I connect to my FTD, it might be the wrong. If I connect to my FTD with SSH, and then to the 10, I believe. It might be the old. Let me check what PATI version is this. 073, so it should be fine. Okay, what's going on? Let me check what is my device. To the device management, what is the management IP address? 10 to 10, so it's okay. Okay, it should be fine. Oh, go figure, right? Remember the password. Okay. Right. So notice I just have one configured role for NAT. By the way, I'm using the new GUI, right, for Firepower Management Center. That's why it's a little bit different that you may have at work. Okay, so if I edit this rule, it's an auto rule, dynamic, to translate all 10/8 to the destination interface IP. Right? So resulting configuration, if I do show run in config NAT, notice that resulting configuration is the object network 10/8, and the configuration is NAT inside outside dynamic interface, which means we're gonna be using interface from the outside, IP address from the outside interface for translation. This is the object NAT. If I do show NAT to show you, display the NAT table, that's gonna be the section 2, the auto NAT policies. That's why I see this rule added in the auto NAT rules in the middle section. And that's the section 2. If I'm going to add, let's say I would like to have my DMZ server reachable from the outside, I can add a new rule, static rule. That's gonna be AutoNAT static. Original source is my server. So either I have here already created object for that server, or I can click plus to create an object on demand here. My or DMZ SRV, let's call it. That's gonna be the host. 72.16.1.50. That's the IP address. Save it. Where is it? Okay, here. DMZ server. Right, I'm translating the source to some address. I can put that address here, or rather I need to add a network object, DMZ SRV underscore NAT. This is gonna be 192.0.2.50. I'm gonna translate to the outside. Okay, I can also add interface objects, so for those brackets, or not brackets, the parentheses. Is it the source or a destination object to have what? To have wait a second, I lost. Okay, I'm here. To have this information inside, outside. If I don't add it, then there's gonna be any keyword used. It's better to be more specific. Oh, it's not inside, outside, actually. It's inside DMZ. Oh, by the way, I don't have DMZ. So I need to add DMZ to the FTD. Jeremy's asking in the chat, assuming FTD under FMC control cannot have config edits in CLI. Exactly. But for FTD local, is it an option? No. No way. So FTD is not being managed locally. The only thing that you can manage is related to the management IP address. So, for example, configure. This is the option here, the configure command. Configure, right? And you have configure firewall, configure network, right? Things like that. Configure network is to configure the IP address for management. So there is no way to configure terminal. Right? There is no such command. Yeah. So no configuration of features via CLI anymore. Right. So notice that I don't have a correct interface. I don't have interface for DMZ in my case. So I can obviously add it, right? My device here. Edit that. Inside outside is only used. Okay, so I need to add a third interface. Give it a name DMZ. Enable it. No mode, the default one. Security zone. I'm gonna create a new zone, DM zone, call it. And IP address gonna be a static IP 172.16.1.1/24. Okay, I need to save it and obviously deploy. But before I deploy, I go to the NAT, and now I should see this interface. And I can add the static. That's gonna be AutoNAT, static. Again, translating DMZ server object to DMZ, to the address, the DMZ server NAT. Between interfaces, between in zone and, okay, lowercase, DM zone. Click OK, and that's gonna be AutoNAT. But notice this, those arrows here. They are pointing in the both directions, which means this is a static. It works both directions. Dynamic, it works only in one direction. Now I can save and deploy. Let me check what was changed. So the NAT policy was changed and the device configuration because there is a new interface. So deploy that. Yeah, but you can do a lot of troubleshooting from the CLI. So all show commands available, packet tracer, debugs, all that stuff is still there. The only thing that you cannot do is the configuration. You can do show. It's so lagging. How is it going with my deployment? It's still doing this. Right. So resulting policy is the NAT table on the FTD, right? So you need to understand manual versus manual NAT versus auto, right? And static versus dynamic. Those four terms are important in order to not be lost in a GUI. Yes, actually, yeah. Do not, you know, this is the lab environment. It's obviously way, slower than the regular real life deployment. Yeah, I know 6.2 this is really bad in case of deployment. But in 6.5, it's I think it's 100% faster than the previous versions. Okay, so do not look at this from in my lab, because in my lab I have like 10 FMCs at the same server, on the same server at the same time. So it's obviously more overwhelmed than a typical environment. Okay, we have that deployment done. If I do show NAT, notice that I have a new entry in the section 2 for my DMZ server. I can also do show NAT detail to see the translation entries or translation information. What are the IP addresses that's gonna be translated? Okay, and now I can even test that. Let me go to the internet PC, and from the internet PC I'm gonna try to connect to my server, which is 192.02.50. 192.02.50. Okay, cannot do that. Can I ping? Yeah, that's a question. Do I have an ACL? Yeah, let's check what is my policy. I believe my policy is quite open now, because I think I was using intrusion policy at the end. Yeah, so I have intrusion prevention at the end. Okay, so what is this? The condition is for HTTP. Okay, that's the HTTP traffic, and the action is interactive block. Okay, so yeah, I should really have an interactive block now. Yes, 50. Yeah, this is the internet to the DMZ. So my current I'm trying to do is this. I have my FTD. I have my DMZ server. Right? So I'm out here. I'm on the internet PC, trying to reach out this way. Yeah, I need to check if my DMZ server is reachable. So it would be nice to first maybe ping. Is this? Why is this so lagging behind? So ping 172.16 1.50, because that might not be reachable. Yeah, exactly. So probably the problem with my connectivity. So let me check real quick in the background. I have all interfaces up and running. To show interface IP brief. And notice the interface is down. Okay, so that's the issue. So give me a second to fix that on a VMware level. That's the FTD. Yeah, absolutely. That's a problem. I don't have my DMZ interface. Okay, it should be up in a second. You're right, Raminder. Thanks for that information. Looks like you are uh, checking what's going on here. Yes, exactly. That's going to be the problem, right? If we do show not detail, from the network, from the IP addresses perspective, that's fine, but inside to DMZ, right? So I should have a result is that there's going to be no route to host in the logs because we don't have the correct out egress interface, right? So this is not going to work anyway. Right, good catch. If I go back to the NAT, exactly, I need to edit this because this is not between inside and DMZ. It's between outside and DMZ. And now, what is the source? What's the destination? Right? It really should be the DMZ to the outside, because remember, when we are configuring static, we always think about the static not for the source IP address, right? So that this original source is where is in a DMZ. So I need to do this. This is the destination. The DMZ is the source. That's the correct configuration. Okay, let's save that and deploy. In the meantime, let me check if I have that connectivity to. It looks like this is really overwhelmed. Okay, now I can ping. I can also do ping TCP. Yes, TCP 172.16.1.50 and specify a port. Check if the port is up and running, if the service is up and running. It's going to send 5 times the TCP SYN to the port specified. Okay, so that should be running. So let's wait for deployment. From the access control policy, notice that we now don't have an access list per interface, right? Because we now have a flat policy. When I go to the access control policies, this is not an access list per interface. It's now one access list for all interfaces. Let's call it this way. So it doesn't really matter which direction the packet will go through. So even if it's outside to the DMZ, I should hit the first rule, right? Because this is about destination port 80, and the action is interactive block, which is this warning message for HTTP, and the continue button to let the user continue. Okay, so that was quite fast, 50 seconds, not bad. Let me check now. Enter, yes. Now access is denied. You're attempting to access forbidden site, and I have a continue button, so I can continue. See? That now works, including the NAT configuration. Okay, I don't want to spend any more time on NAT because we already covered NAT config in ASA, but this is exactly the same thing, but the configuration is a little bit different because it's using GUI now and not CLI. But the resulting configuration is exactly the same. Okay, we will be obviously doing this later in our lab. For example, in case of VPNs, some VPN traffic will not go through because we have translation and we need to exempt from the translation. So we'll get back to the NAT configuration for sure later. But now we can just go to the next topic, I think. If you need more information about NAT and those resulted configurations, you need to go back to the ASA. That's why ASA lecture was so important, because half of the features on the FTD are actually taken from the ASA, and you need to know that anyway, how it works, how it behaves. Okay. So let's take a look at the QoS real quick. So QoS on FTD, it's only available on the FTD because the QoS was fully ported from the ASA as a feature, but it's a little bit extended. So it has more capabilities than a QoS on ASA. That's important. That's really interesting. So QoS feature, actually the only QoS feature that we have, which is policing, no traffic shaping, came from ASA code again. Okay, but it was enhanced by some firepower related features. By some For example, you can use to specify what kind of traffic will be subjected to policing. You can specify that with using the URL categories. For example, you can create a policy saying, I want to limit the bandwidth to shopping category, URL category. Right? That's pretty cool. And also you can use application detectors for that. Something that wasn't available on the ASA, application detectors for QoS. Okay. And very important thing is that the QoS is a per interface feature. It's a per interface. Because you need to specify, okay, I want to do the policing on the outside interface or inside interface, depending on what you're gonna want to achieve. So for example, if you have, say you have a client here, FTD here, and some server here. Right. This is in, this is out, or input as outgoing and incoming interface. Okay. Then you need to specify input or output. This way, this is input. So this is the input on the inside interface. Okay. This is the output of the outside interface. So notice for example, if you are downloading something from the server, if you are downloading from the server, right? Actually, what you're doing, what you need to have a feature enabled to affect this download on the outside interface in the input direction. Right? If you want to affect upload, then input on the inside or output on the outside. Okay? We'll see that in a second in action. And the final thing is that only polysync is supported. Right? Polysync is supported, which is basically when you have your traffic, let's say this traffic going this way, there are some peaks, right, this way. If you are polysing something, you are doing this, and everything above is gonna be dropped. Okay? So everything above will be dropped. You set the polyser on a specific level, on a specific throughput level or bandwidth level, and you keep that level. Everything exceeding this level is gonna be discarded. So there is no way to do the shaping. Shaping is when you have this peak here, you can use this lower bandwidth usage time to send that data. So polysync is more strict. Shaping is buffering some data and trying to send all the data without any packets being dropped. But polyser is just looking, okay, if it's exceeding this level, I need to drop it. Simple like that. So how it looks like. It's a separate policy under the devices QoS. Okay, so you need to create a new policy and apply it to a device. You can click a new policy or the button new policy. There's no question, like with NAT, is it going to be the firepower or FTD, because the firepower does not support QoS at all. So that's why only FTD can support that. You give it a name like FTD QoS. Select your device to apply that policy to. Save it. Okay, and I'm creating rules. Give it a name like let's call it limit download, okay, or web download. Oh, it's better, web download. Right, and I need to apply this QoS on a per interface. So I need to choose, okay, on which interface am I going to apply it. I could apply it on the output, or sorry, on the outside interface in the input direction, right? Because that's going to be the download back to the client traffic. So I'm going to select, see, interfaces in the source interface object or destination interface object. So here we apply, for example, the source is going to be out. Okay, and we can leave the source to apply that on the outside. And then I set the download limit. Let's say 1 meg second, or maybe let's do that, do less, like 0.2 megabits per second. Okay. Upload will be unlimited. And then I can specify, okay, which networks this QoS policy should affect. Okay, so I can say, okay, all networks in my n/8. That's the source. Users, applications, so application detectors I can use for that. Ports, if that's only for web, I need to specify HTTP and HTTPS. Okay, or URL categories, or some attributes from ICE. By the way, if I do interfaces in source, that's gonna be light. Okay, but this is not the source. The source is I'm looking at this from the client's perspective. In my case, that's gonna be the destination, and the destination is the outside. And the download is the returning traffic. Let's save that and see what's gonna be the resulting configuration on a device if I deploy this config. Again, so device configuration changed, specifically QoS policy. Deploy that. And the QoS policy, like on the ASA, likewise on the ASA, it's modular policy framework, MPF config. So I need to check my MPF configuration for a specific action, which is the policy in this case. If I do show service policy, that should reveal that. If I can. Not sure why is it so overwhelmed at the beginning of the deployment. Okay, the deployment is successful. Oh, not yet. Still working. Let me check the console connection. See, the console is not that affected. If I do show service policy, okay, that's I cannot scroll in that window, so it's better to use this SSH connection. Let me check if I can, maybe I have something on the server enabled that is so overwhelming. Okay, let's do service policy. Make this a little bit bigger. Okay, so it's showing me the service policy that is there on a device. Okay, here is a global policy, right, which is basically the inspection for different layer 7 protocols. But also now I have an interface policy, a policy assigned to the interface, the outside interface. Service policy name is the policy map outside. Notice the flow rule QoS is some number here, which is the QoS policy. And this is the input. So this is the input policy on the outside interface with a committed rate of 200,000 BPS, right? Bytes per second, which is basically 0.2 megabits per second. Right now I have some packets going through, 15 packets, but confirmed to that policy, not exceeded. So let me go to maybe my employee PC, which is the inside host. And okay. And I'm going to try to download something from the internet and see if I'm exceeding this policy. Okay, I'm trying to open the Firefox, so probably some updates is coming. Oh yeah, here we go. Come on, man. Don't want to waste time here on opening the Firefox. What? Let me. Have a couple of unnecessarily enabled VMs on the same server, so I get rid of those. Just to speed up a little bit. Okay. Right, so let me go and do Debian ISO file download. No, that's not my home. That's not my home connection issue. That's a lab network issue. Okay, let's download some DVD or over HTTP. Right, that's the it's over HTTPS. Oh gosh. I think I selected only the HTTP. Let me check. Oh no, HTTPS is also okay. Oof. Let's try to download a DVD file. Okay, and see what is the speed. 22, 23, 24 kilobytes per second. So this is 0 to megabits, 200 kilobytes per, no, kilobits per second. Yeah, that would be it. Right. For example, if I go to my DMZ server, have access to it. Yeah, I have it. Yeah, but my server is not limited because it's not going through the policies applied to the outside. Let's check if I have some exceeded packets in now. Right, so I have 1,481 packets exceeded. This is almost 2 megs, and the action is drop for exceeded packets. Right, so that's really bad for the traffic. Okay. Right. So the next thing I wanted to talk about in this class is the pre-filter. And with this feature, I would like to talk about a little bit more about architecture of the FTD. So that's gonna take us like 1 hour or so to go through this, because I would like to show you some deep dives on this. So I think it's a nice time to take a quick break for a coffee, and then we're gonna be. I need you all to be fresh and ready for very important, but also, let's say, very weird and difficult section. So let's take 15 for a coffee, and gonna be ready for a hard stuff. Coffee break. Okay, so see you guys in 15. Okay, guys, let's continue. Okay. Yeah, so the next topic is quite an important topic, is the pre-filter policy. So pre-filter policy is FTD only feature. It's not possible to have a pre-filter policy applied to the old firepower device, even if you are managing the other old firepower devices with FMC. This is just FTD related feature, and you will know why in a second. But before we go into the feature itself, let's take a look real quick, refresh our knowledge about how the packet flow is through the FTD. And the packet comes on an ingress interface, right? Then we do the DNAT, destination NAT. So we are unnatting packet if that's necessary. Then we check the routing. Right? Then we check if the packet belongs to already established connection. And if no, if that's the new connection, then we go through the access list, like on the ASA. Right? Then we go to the NAT rules and check if there is a NAT rule for that packet, because this NAT rule can redirect the packet to the different egress interface. Right? And then we go to the inspection. And the part of the inspections actually here, we are sending the packet to snort or delivering that packet to snort. In the snort, we have preprocessors. We have security intelligence. Those are typical features taken from the firepower. SSL policy or SSL decryption if that's configured. Security intelligence again for URL and DNS. The first security intelligence is just for IP address, the blacklist, right? And then we have access control policy. And in the access control policy, per rule, we can send the packet to the IPS for additional inspection, and to the file policy to check if that's a malware file that is being downloaded or something like that, right? And the packet goes out, right? But it's not the end of the flow, because the packet is returned to the ASA, where we have source NAT. So the translation of the source IP in the packet is done here. The QoS, we already talked about this, is here, but it depends, right? The egress interface QoS is here, because ingress interface QoS is here. So depending on where the feature is applied to. Then we check for layer 3 next hop to send the packet to the wire, and we need to have MAC address for the next hop. So we check layer 2 adjacency, and the packet is out on the wire. Right? And this middle section here, the snort, is everything that we have from the firepower. The other things at the beginning and the end are ASA related features. So it looks like this. We have ASA code, then we have some snort code and features, and then we have ASA code again. Okay. So now the problem is that when you are managing all of this with FMC, so this is basically all that stuff is basically our FTD. That's our FTD, Firepower Threat Defense. And the manager is FMC, is the manager. So we are managing ASA features, right? Or ASA, yeah, taken from the ASA with FMC now, right? As we done for NAT and QoS just before the break. Now, if it comes to the access control policy, when we apply the policy, the firepower rules or firewall rules, the access control policy, if it's being applied here, because that's our policy. And per the policy, we can send the packet to the further inspection by IPS or a file policy. But also, this file policy is being delivered here, this access list, and it's affecting this access list, right? But we have another feature that is affecting this access list called a pre-filter policy. So the pre-filter policy is being applied directly here to this access list. So think about bypassing traffic, because that's a #1 feature for the pre-filter. Pre-filter policy, reason for that policy is first to bypass traffic. So if it comes to bypassing some traffic, let's say you have some voice or maybe some backups. So huge amount of data is being sent through the device. Do we really need to inspect that data? I don't think so, right? It's just a backup. So we want to send it as fast as possible through the device without additional inspection. We don't need to send that traffic through the security intelligence, through the IPS, all that stuff. So it's a nice candidate, right? Example is backup traffic. Right? It's a nice candidate to bypass. So where we can bypass, we could possibly do a bypass here in the access control policy by simply configuring a trust rule for this backup traffic. But the trust rule here, right, will be enforced here. So the packet will need to go through all the way here to the preprocessor, security intelligence, SSL decryption, stuff like that, up to the access control policy to be bypassed. Finally, right? So that's not the way to go. It's not the optimal path. It's better to bypass this as soon as we can in this process. So this access list is a nice candidate to apply a bypass. That's why if you're configuring pre-filter policy, you are affecting this access list here. Okay, and you configure a bypass here, bypass rule, and this packet will be bypassed, which means it will go straight here to the egress interface, which is here, egress interface. Right? It goes here and out. That's one reason for pre-filter policy. Another reason for pre-filter policy is to deal with tunneled traffic. Example of that traffic is GRE. That's a tunnel. Okay, and that's a thing that came out with when they or developers tried to combine two softwares, ASA and Firepower, because in case of the tunneled traffic like GRE, ASA behaves in a different way than Firepower. ASA can do the filtering or allowing packet or dropping the packet based on the outer header in a GRE, but Firepower can do that based on the inner header, so what's inside the GRE. Okay, so in the tunneled traffic, we can filter the tunneled traffic here in the access control policy. So in this access list, we cannot see what's inside. In this access list, we can see what's outside of the tunnel. So we see the tunnel source, tunnel destination only. Okay, so that's another issue, and that's why pre-filter policy is usually just accepting the GRE as such, or GRE or other tunnels like IP and IP, Teredo from Microsoft, other tunnels, just allowing those tunnels to go through so that they hit the access control policy and can be filtered by the access control policy based on what's inside the tunnel. Okay, that's the important thing. Let me show you what I'm talking about in the lab. Okay, so that's gonna be easier to understand. Let me show you the access control, or maybe let me show you the access control policy first. So I go to policies, control. I have my policy already here, and this policy has two entries, actually three with default action. One is allowing the HTTP, but conditionally allowing, because the action is interactive blocks of this website to the user. And the next one is the web access, which is basically allowing everything, okay, and sending that packet or this traffic to the intrusion policy, to the IPS. Because IPS is applied here to this rule. Okay. So let's take a look how it looks like if I do show access list. So show access list reveals this access list here from the ASA. And notice that now I have two sections here. One section, so access list entries line 1 to line this one to line 7, including. Those are the pre-filter policy tunnel rules, default tunnel action rules. Notice that there are tunnels like IP in IP, 41, remember what this protocol is, GRE, which is a 47, and UDP 3544 is Teredo, Microsoft Teredo tunnel. Anyways, those rules are just permitting, notice the permitting any tunnels, regular tunnels. I'm not talking about IPsec, okay? Just tunnels like GRE or IP and IP, just permitting them. And then from line 8, right, we have our access control policy. Access control policy and our rules. So first I have conditional web access rule, and then the second one is the web access rule. Okay, so those rules are being applied to the access control list on ASA. But depending on how we're gonna create those rules, we may have a different action here. So notice, for example, I have my conditional web access rule. In a GUI, it has action of interactive block. ASA has no idea about that. So ASA code has no idea about action interactive block. ASA knows about permit or deny. Right? So what is here instead of interactive block? It's permit. Because we need to permit that packet all over the way to first allow it here in by this access list to be interactive blocked here in the access control policy. Okay, the next one is allow, right? The second rule, and the second rule here has an action of permit. The one. Okay, so let me actually go to the GUI and change a little bit those rules. So first off, let me add a rule called web access. And instead of interactive block, I will just say allow. Okay. Web. Okay, let's call it just web. Okay. Or maybe, yes, it's just for better understanding. Let's web allow. So it's like an action. Web allow. Second rule is gonna be for some backup. Let's say backup trust, because I want to bypass it. I don't want to inspect backup. Okay, so let me change it to trust and add some networks. Like it's doesn't make any sense. Okay, so the destination server is DMZ server. Let's say this is a backup server. Okay. I can also add some ports, but do that anyways. I'm just trusting this. Okay, something is wrong here because of what? It doesn't make any sense to me. Can it be yeah, I don't know. Okay, so I need to get rid of the intrusion policy, file policy. I want to use trust. Okay, save it. Okay, so the second one is to trust. Let me add another one. I'm gonna use some application detectors like Facebook. FB allow, let's call it, or Facebook. And instead of specifying IP addresses, I'm gonna specify the application name Facebook. Facebook add the rule, and action is allow, and I want to send that traffic to the IPS. Okay. Okay, why don't I have it in here? Get rid of that. Right, so I have users to internet. Okay. 3 rules, and the default action is send it to the IPS. So anything that is not allowed here, you're gonna send. Okay, I can also block something. So I have everything. Let's call it test block and use something like from 192.168 to 16 to port AOL, whatever the port is. I want to block that. Right? So 4 different rules plus default action. Okay, save it and deploy. So pre-filter ACL, right? It consists from 3 sections, let's call it. Section number 1 is the pre-filter rules. Section number 2 is pre-filter tunnel rules. And section number 3 is access control policy rules. Right, so this access list, you're gonna see, is like this. Obviously, this access list is being examined top down, first match. Right, and here in those two is the pre-filter policy, and we have actions here like this. Analyze means permit. Block means drop. And fast path means bypass or trust. Let me show you that in a second, but now we're going to focus on this part, on the access control policy rules. Okay. Here are the actions, access control policy actions. We have what? Trust, block, allow, right? And other things like interactive and so on. So we'll, in a second, we'll take a look what is the result in this access list. So again, in my example, what I did, show that again, I have 4 different rules. 1, 2, 3, 4. One is having allow action. This is just the web allow, so HTTP allow. Second is backup, and the action for it is trust. Right. Third is block. And fourth is the Facebook allow. Facebook, and the action is allow, and plus IPS. Right? And then we have a default action of IPS. This is our example access control policy. Now let's take a look at our lab after the deployment is finished. Right, we're done. How this is gonna look in on a device. Come on. Really? Sorry, I copied that, but then I cannot hit enter because it's not. I cannot hit enter. Yeah, right click. Exactly. Annoying thing. I would restart the session quicker than this. Sorry. That's embarrassing. Okay, finally. So now if I do show access list, that's going to reveal the truth. Let's skip that pre-filter policy rules first. Let's take a look at the access control policy. From line 8, we have access control policy. And the first rule is web allow. Right? If it's allow, meaning that we're going to permit here. So allow means permit. Right? If I go back to here, allow means permit. Let's take a look at another rule. Another one is rule backup, right? That's the second backup. And the action was trust. What do we have here? Notice for a trust, we have a permit. Okay, what about block? Number 4, test block. And the block is deny. That's the obvious one, right? Deny. And what about final for Facebook? We have allow plus IPS. And for the Facebook one, we have Facebook allow, permit. But notice how this rule looks. It's a permit, IP any. So there is no information about the Facebook application, even though our rule is using application detector. And that's because ASA has no idea about application detectors. Okay? You can actually see it if you take a look at something that is called rule ID. This rule ID applied to every rule. This rule ID is a number that's gonna be, let's say, when the packet hits this rule, the packet will be tagged with that rule, and the snort can understand that. The snort can do what it needs to do with that packet. So how we can check that, correlate that with the snort? And this is going to be a very deep dive now. You need to type in expert, and you go to the expert mode, which is basically direct access to the Linux underneath. Okay. If you go to the var SF, then detection engines, then hit tab, because there is some just a number for a snort process. If you move to that directory and do list, you're going to see that there are some different configuration files for snort. And we have a file called ngfw.rules. If I do more on that, ngfw.rules, notice that this is the my ACP, my access control policy. I see the version, notice the DC acronym. So this is FMC. Right? Remember the old name for FMC? Defense Center. That's why they still call it DC in the files. We see SRU, which is the snort rule update version. We have VDB, vulnerability database update. And we see the policy. And here are our rules in our policy. And notice those numbers. Let me check that number for my Facebook. My number for Facebook was ending with 4440. 4440. Right? On a snort, it looks like this. Allow as an action, any. The next thing for a packet is the IPS policy number 4. And by the way, this rule is only for the application ID 629:7, which is basically the Facebook application detector ID. Okay, so this is how those two things are correlated to each other. Okay, but how about this bypass? So if I configured for my backup bypass, I configured the trust role. Notice that it was resulting. Oh gosh, right, wrong Windows. It's resulting. With a policy or a backup role of permit, which means, let me open up real quick. Give me a sec. I need to open the previous drawing. Share that with you. Okay, here we go. Back to that drawing. So notice that for our backup, the access control list says permit that packet. Permit means this packet will go all the way here to snort, preprocessor, security intelligence, SSL decryption, up to the access control policy. And finally, it hits the access control policy trust rule, and it will be trusted here, from here, which is a really, really bad idea because it's a waste of resources. We don't want this backup to go all the way up to the access control policy. It would be nice to say here, please trust this traffic. Let's bypass it here in the access list. We cannot do that with the access control policy trust rule. Okay? But we can do that with a pre-filter policy fast path rule. So let me show you now the pre-filter policy instead of access control policy. For a bypass, you basically go to the pre-filter policy, most likely. Okay, so there's a question in the chat about what if this is for the first packet. What about other packets in the connection? Good question. So if you have yes here on the connection, right, which means that this packet is a subsequent packet of the already established connection, this is gonna move through the access control policy, so it will not hit this access control policy anymore. It will also not hit the NAT rule check, not hit inspections, but it will go to the snort anyway, because snort must see every packet. Right? Remember, in case of attacks, an attack can be in any packet from the flow. Right? So if it comes to the IPS, signatures check and all that stuff, you must see every packet in the connection. You cannot say, yeah, okay, so that's 2 packets are okay, so everything else will be okay as well. No, every packet must be inspected by snort in this case. Right? So this is how it works. It will not hit access list anymore, but it will hit snort anyway. Right, let me go to the pre-filter policy. Notice here, the pre-filter policy is already assigned. The pre-filter policy name is default pre-filter policy. I can click on that, change. Obviously, I don't have any other pre-filter policies. Or I can go to policies and pre-filter to configure my own pre-filter policy. Why I want to configure my own pre-filter policy? We'll see that in a second. Because you cannot add rules to the default pre-filter policy. You can change only the default action. And the default action says analyze all tunnel traffic, which is basically about tunnels only. You cannot add a rule for bypassing traffic to the default pre-filter policy. You need to get back here and create a new policy. Let's say my pre-filter. Call it. Save it. Nice question in the chat. Do you have companies trusting backup as a rule of thumb design? What if backup has malware, bad agents wouldn't? Yeah. Yes, that's actually, I think it's a not the best practice, but this is the practice that everybody is using because simply because we, especially in a devices like with devices like firepower, simply because the firepower needs to analyze every packet. So it's going to be overwhelmed by the number of packets that you are sending through in case of backups. So you need to, um, you know, potentially, right? Someone could spoof the IP address of your backup server, knowing that the backup is not being analyzed. But this is really hard to do. So it's not a real, let's say, not a real danger. Right? But yeah, answering this question, yes, everybody's doing this way. That's my at least my experience. Okay, so I created my own pre-filter policy. That notice now I have option to add rules, tunnel rule or pre-filter rule. Let's leave tunnel rule for later. Now let's add a new pre-filter rule because I want to bypass traffic. So that's the pre-filter. Notice that pre-filter has a analyze, block, or fast path option, action. And fast path, as name implies, it's a bypass. So let's say backup bypass with a fast path. Okay? Again, say network. Let's say DMZ is my backup. DMZ server is my backup server. So everybody to the DMZ server is gonna be bypassed. Click add and save it. Obviously, in order to use it, I need to go back to my access control policy and select the newly created pre-filter policy, not rely on a default pre-filter policy anymore. My pre-filter, okay, save it and deploy. Okay, so access control policy changed and the pre-filter policy is new. Okay, deployed. Okay, so what are we expecting to have now? So since we already know that this access list is actually consisting from 3 sections, the pre-filter rules, pre-filter tunnel rules, and the access control policy rules, we should have the same thing, except at the top of this access list, there should be the pre-filter rule that we added. Right? The pre-filter rule with a fast path. Yes, you can. Yeah, in the chat, there is a nice description, simple description for a pre-filter. Yeah, this is the access list on the ASA. At the very beginning to bypass at any other inspection. But this is the bypassing traffic is only one feature of the pre-filter. Another feature is to deal with the tunnel traffic, which we're gonna take a look at in a second. Okay, that's the deployment is over. Let me get rid of of the expert mode, get back to the regular shell. Come on, what's going on with that? That overrun is the first time I see that this is so lagging. Come on, guys, I don't have time for that. Something wrong with her. See, I cannot hang it. Okay, do we have any other device on that IP address, maybe? Let me check real quick. Okay. I think so. No, I don't see any other devices enabled. Okay, let's move on. So show access list now. Now my access list is the pre-filter policy, my pre-filter, that's my policy. And see the number one role is my backup bypass role. And notice what is the action here. It's a trust instead of simple permit. See the difference between backup bypass role in the pre-filter policy and backup trust role in the access control policy. The trust will result in the permit. The backup will result in a trust action. So you can ask yourself now, okay, wait a minute. So is ASA capable of doing action trust? I thought that it's only permit or deny. Notice that this is a new way of a new type of the access list. ASA, regular ASA supports only standard or extended, access list. Here we have a special access list called advanced, which is having some additional options, additional actions, like trust. And this trust means that the packet will be bypassed here. So here, when we hit that trust rule, this access control policy ASA code will deliver that packet to the egress interface and send it out. So the whole snort, all inspections, everything like this is omitted. Okay. By the way, there is another nice feature here, because when you have a hardware like 4100 or 9300 firepower, then this trust rule will be automatically applied to the hardware, because only 4100 and 9300 hardware devices have something called a smart NIC. Smart NIC is the programmable interface card that can program things like this. So this bypass on a 4100 or 9300 will not be done here in the software. It's going to be done here and at the ingress interface. Wire speed. You don't need to do anything else. It's all automatically programmed in the hardware. Okay. Okay. What about this tunnel traffic now? As I said, this is for tunnel on also. Remember how the tunnel looks like? You take a look at the GRE tunnel. I'm going to be talking about GRE tunnels a lot when it comes to the VPNs and the DMVPN and stuff like that. If you have a tunnel, GRE tunnel, you have data in a packet. The original packet is like this, IP and some data. Right? When it comes to the GRE, GRE is encapsulating the whole packet, adding the GRE header, and also, since it's encapsulating the whole packet from here to here, it must add new IP header to be able to route the traffic. For example, the original IP was 10.1.1.1 to 10.2.2.2, right, and some data, but the GRE header is the GRE tunnel source and destination, maybe some public IP addresses like 100.1.1.1 to 200.1.1.1. And guess what? This is seen by the ASA. This is what ASA sees. ASA cannot look into that GRE packet. By the way, the GRE packet by nature is not encrypted. We're not talking about GRE over IPsec, right? So no encryption here. This is just a clear text, tunneled packet. So ASA is only ASA code is only capable of doing this, to inspect this packet on the outer header. But firepower can inspect here based on the inside header or inner header. Right? So now if it comes to our pre-filter policy, this is the access list, which is the ASA thing. So the access list here must permit that the GRE packet first on the outer header to send it, to allow it, and send it to the access control policy, which can understand what's inside the tunnel and make a decision, filtering decision based on what's the inner header. Okay, so this actually, this, okay, here is for tunnels. And we have tunnels like IP in IP, GRE, or Teredo, Microsoft Teredo. Those are the three most popular tunnels. Also, there is another one, right? The 41. What is the 41? Let me Google that for you guys. IPv6 in IP. Thank you very much. Right, so I couldn't even open the IPv6 in IP. This is 47. IP in IP. This is 41, right? Teredo is the UDP packets, and IP in IP. I don't remember the IP in IP. Anybody? What is the protocol number for IP in IP? IP in IP protocol number. Protocol number. IP 94. 94. Oh, by the way, I'm not sharing that, so show you Firefox. This is the protocol numbers from IANA, and 94 is IP, which is IP within IP encapsulation. 94. 94. Oh, okay. Just to be here. Okay. So back to this for a second. So ASA looks in the outer header, but here firepower or snort, right, looks in this is outer and inner header. Okay, that's why by default, even if I didn't configure that, by default, the default rule, right, in my pre-filter policy, what was the default rule in my pre-filter policy? Let me show you that real quick. My pre-filter, analyze all tunnel traffic, right, which resulting in what? In permitting IP in IP, permitting 41, permitting GRE, permitting Teredo. Okay, so all well-known and popular tunnels are being permitted based on the outer header, because the GRE or that information is basically in the outer header. What is the protocol? Right? And this is just permitted for one reason, because this packet must go up to the access control policy and can be filtered further based on the inner header within access control policy by the access control policy rules. Okay. This is how it's quite complicated. Now, if just to make it a little bit easier for you guys, so how we can bypass the traffic? How we should do that? The obvious choice is to use pre-filter policy and a fast path action. This is what you should use, okay? Because this is done by ASA code, the access list, right? It's an early bypass. Okay? And by the way, depending on the hardware, it can give you some even hardware bypass. You can achieve hardware bypass. Okay, remember I said only on 4100 and 9300, okay, they use smart NICs. That's why this hardware is so expensive. It's way more expensive than 2100, right? So 2100 or 1000 is not using smart NICs. They don't have those. And those smart NICs are programmable interfaces. Right? Like ASICs. So you can achieve hardware bypass, wire speed bypass. You're not doing any inspection whatsoever of the packet because it's being bypassed on the ingress interface here, wire speed. Right? So it's not even going through the ingress interface check like CRC and other things, the destination NAT routing, right? Connection is not being checked. You're not affected by those things at all. Or another option for you to bypass traffic is to use access control policy trust rule. Right? But this is, I consider it as a software bypass. Okay? It bypasses what? If you take a look at this picture, it bypasses actually what? Here, the IPS and the file policy. Right? Bypasses IPS and file policy. Maybe plus obviously the QoS and stuff like that. But, okay? But not bypassing, that's more important, the security intelligence, so blacklists and preprocessors. And that's really painful because preprocessors can drop packets even if you don't know that. Even they can silently drop packets sometimes. So you need to be careful with that. And they are quite overwhelming. I mean, they impact the CPU a lot, especially if there are a lot of packets. Okay, so that's the thing to consider. Not bypassing security intelligence and preprocessors. Okay, that's why if you want to bypass, the first thing to go is to use the fast path action in the pre-filter policy for that. Okay, cool. 1 hour passed. Let's take a quick break again. And the next thing I wanted to talk about today is the network discovery, which is, again, very important, because without the network discovery, we will not know about any vulnerabilities, and we will not be able to tune our IPS, which is quite important if you want to deploy that device in a controlled way. So stay tuned and join me in 15 minutes. Okay, so let's take 15, grab a coffee, and be ready for network discovery. Okay, see you in 15, guys. Guys, let's continue. And the next topic for today is the network discovery. So, network discovery, or ND for short, call it ND. Okay, so if we have FTD in our network, let's say, in this case, FTD is on the internet edge, protecting our users from 10 network. In our case, in a lab, we have 10.10.9.0 network, which is actually the 9100, which is the employee PC. Right? That is going out to the internet. Obviously, this is managed by FMC in our lab. And the network discovery policy is by default there, but the feature will be not doing or creating the host profiles, which means the default network discovery policy looks like this default. 0/0 and 0:0, which means all IPv4, IPv6. The action is discover applications, right? Which is very important, because that means simply that the protocol detections or application detection, the detectors are working on the FTD for all traffic. So we are not learning, but understanding what is the traffic going through the FTD. So discover application. This is actually based on a default entry in the network discovery policy. So let me show you that real quick. I go here under the policies. I have a network discovery. And notice the default is this 0/0 and :0, which means all IPv4, all IPv6. The action is discover applications, which basically just taking care of application detectors. It's not configuring or not creating host profiles. host profile, right? We already talked about this briefly, is only created when we have discover and hosts enabled. But if you go here and change the default, because you can edit the default rule, and instead of just saying applications, which is actually grayed out because you cannot uncheck it because you're gonna broke the system, you can additionally check hosts. But that's gonna be very bad decision for you, especially if your FTD is on the internet edge, because you're gonna start creating host profiles for all IP addresses. Doesn't really matter if the IP address is private or public. Okay? So this is very dangerous. So what is really recommended is to add additional rule here saying my network is 10/8 and I want to discover hosts. Okay? So application detectors work anyways for everybody, but we also add our network to discover hosts. That's gonna create a host profile or host profiles for our hosts. For example, in my case, that's gonna be host IP 10N9100. Right? The type of that is gonna be host. Different types like load balancer, some network device, mobile device, if it's a tablet or something like that. Then we can try to discover what is the operating system. In my case, I have Windows 10, so it's gonna be Windows 10. What are the applications? So maybe I have a Firefox 62. Maybe I have Internet Explorer, or actually that's on the Windows 10 is the Internet, it's the Edge, right? It's not the Internet Explorer anymore. But anyways, this is just an example, or some usage of SSH client like PATI. Maybe I have some services enabled on that host. So if because the host profile can be created for both source and destination. If it's under the network discovery policy, right, which means if the destination is also in the 10 network, that can be the server, then we have a services there, like TCP 80. On this port, we have Apache 2.2 running, okay, something like that. So we are trying to find out as much as possible just by passively scanning the traffic between client and the server. And we build the host profile only for those who are mentioned in the network discovery policy, included in the network discovery policy, and have action to discover hosts. Okay? So in my case, a good practice should be, instead of doing something stupid like this, because if I add this option to the default, that means I'm gonna start, my system will start creating host profiles for internet-based hosts, which is completely unnecessary. I don't need that information. I don't need to know what's on the public host. I don't need to know what are the potential vulnerabilities on that host. I'm taking care of my hosts, my network. This is what I'm protecting. I need to know what's on my side. So the good practice, the best practice actually, is to not touch this default rule, is to add new rule with the action of discover for your network that you're protecting. For example, in my case, I'm protecting 10 network, but also in In a DMZ, I have 172 network, so I need to add both with the option hosts. By the way, there is also an option to discover users, which is, in my opinion, not very useful anymore, because this is the way to discover users in the packets. For example, if someone is using, I don't know, FTP connection, right, and it's logging to the FTP server, if the login is going in the clear text, the username is going in the clear text, we can catch that information and apply that info to the host profile. But what is the reason to have information like anonymous is on the host? It doesn't really make any sense. It makes sense if it's a real user, like maybe if I'm looking into the LDAP, right? But nowadays everybody is actually securing LDAP with SSL, so we don't see that anyway. So I think it's useless, this option today. So this is what I would do. I would add my protected networks and select action of discover hosts and applications, because that's always checked. Okay. If I would like to exclude something from that, maybe one of those networks is not belonging to me, it's belonging to some partner, like 1 network, then I can exclude. I can add rule and say exclude instead of discover. Okay. For a network 10, I don't know, 55.0/24. Okay. So this is going to be excluded. This policy is not like typical firewall policy, so we are checking the entries top down first match. No, it's basically the exclude going to be more important than include, than discover action. Okay. So this is how it looks like. On the users tab here, we have different protocols that we can enable or disable that the system, the FTD, should look into for a user information. Right? So for example, this FTP, but what is the reason, what is the advantage of having or of knowing that the anonymous user is on a host? Useless in my opinion. LDAP is cool, but since LDAP is encrypted nowadays, not really doing anything useful here. So I would say the whole feature is not really useful. On advanced options, we have some option to capture banners. What does it mean? It means that some services, like FTP, for example, is presenting banner to the user during the connection. So we can capture that banner and add it to the host profile, so we better know what the service is running, what is the service or server version, and so on. So that's just for informational purposes. Another option here is what to do with conflicts, because that information by default is from the passive scan. But we can also use some active scanning tools that we have, like usually third-party tools, like maybe Qualys, Vulnerability Scanner, Nessus, okay? Those kind of tools. If they are scanning our network, they better know what's going on and what's on a particular host. Right? And that information can be injected to the Firepower Management Center. If we are injecting that information, that active information coming from the active scanning tools, we have like conflict, because we have, let's say, operating system from a passive discovery And we also got the information about the operating system from the active scanner. So we need to manage that conflict. Okay, so we can automatically resolve conflicts by keeping some information like active or passive, okay, information. So obviously the active is better. By default, it's disabled, so it means we're gonna have both information in the packet in a host profile. Okay. We'll talk about this in a second. Yeah, okay, let's do that. Because the most important thing about building a host profile is not that information that we have in the host profile. Actually, is something else. It's ability for this system to map vulnerabilities to the components that were discovered on that host. What does it mean? It means, for example, that Windows 10 was discovered, and we know that based on the CVE, that Windows 10 is actually vulnerable to this CVE or to this vulnerable. Yeah, there's that vulnerability on a Windows 10. Okay, maybe Firefox we discovered 62 is vulnerable for something else. So we map that vulnerability from the CVE and so on and so forth. So we map all the vulnerabilities to the things that we already know of. And now that's the biggest thing about that. Now that information tells us what are the potential vulnerabilities in our network today, now, in that very moment. And we can use that information to tune our IPS policy. We're going to talk about this probably next week. Okay. So use to tune IPS policy. Okay, we can tune up our IPS policy based on that. As I always say, this is a list of potential vulnerabilities. The potential because we never know. Okay, what, for example, this Windows 10, what is the patch level of that system? Maybe this is a fully patched system, but what we can discover from the passive scan, we only can discover that this is Windows 10. And we can map all vulnerabilities for Windows 10, no matter what, if we have a hotfix for that already applied or not. A CVE is just a public database. It's a common vulnerability and exposures. This is a database of public database of already known vulnerabilities. And the Firepower Management Center is downloading that information from the internet, updating that. Okay. So remember the VDB, vulnerability database? This is the database that we are downloading. Under the system, here, updates. Right? We have a product updates. So those are the patches that we may apply to the system. But also, let me click download updates. So the system can go out to the cisco.com and check out for new updates. And on this list, on the product updates, there can be a VDB update, vulnerability database update. It doesn't, comparing to the product updates like patches, notice that the reboot is required to apply the patch. But in case of the vulnerability database, the reboot says no, it's not really important. Because that's very important. Notice that the host profile is not something that is stored on the FTD. It's stored on the FMC. And it's a job for FMC to apply vulnerabilities to that host profile based on the latest VDB. Right? VDB is called. VDB. Vulnerability database. Okay, so let me put it here, the best practice of configuring network discovery policy. The best practice is to always configure network discovery policy to include your protected networks. And the policy to include your protected networks. The networks that you are protecting, to be exact, right? So this should be an additional entry in the network discovery policy. Notice when I get back, okay, it's still thinking, so I can get rid from this screen, but it still be going. So it's a kind of job to do. So we can get check out later if the new vulnerability database is there. And let me get back to the network discovery policy. Notice when I have that network discovery policy, there is no save here. And notice that it's saying out of date on one targeted devices. The very important thing is that this is the one of those policies that doesn't need to be applied to the access control policy in order to be deployed on a device. The network discovery policy is going to be applied to all devices that you have under the devices, right, registered to the FMC. You need to be careful with that because there is no way to apply network discovery policy on a per device basis. It's going to be applied to all devices at the same time. So when I click deploy, right, now network discovery is being going to be deployed on my device. If I have 10 other devices, the same network discovery is going to be applied to those 10 devices. Okay, so let me apply that and then generate some traffic from my employee PC out to the internet. This traffic will go through the FTD, and the FTD should notify my FMC, and the host profiles will be created on the FMC. Okay, check that. Okay, still going. Go to the employee PC. Okay, let me connect to cisco.com. I think I'm having problem because I'm now limited to 0.2 megabits per second to download. So that's might be difficult. So I need to get rid of the QoS policy from a device. CNN.com. Let's open that one as well, or try at least. Why this? That's why this is so slow. Let me open a simple site like this. It's still very, very fast. Okay. Anyways, I just sent some traffic through the device. Now I can go to the analysis and hosts. Here is the whole bunch of information about the host. I start with a network map. Okay, so as you can see, I have now two hosts discovered. They are being grouped. That's why this is called network map, because they are being grouped based on the networks. Well, now we have three even. 10.10.9 network, right? In 10.10.9, I have 10.10.9 101. Okay, this is 101. Here, let me check. IP config. Yeah, that's 101. That's the IP address of that guy. When I click this IP address, I should see the host profile built for this host. Okay, yeah, see this, the IP address is correct. The MAC address, the host type is host, last seen. We don't see any indications of compromise, so no security related events for that one, for that host. We see the operating system is Windows. Oh, actually, server. Okay, so there must be some more packets sent in order to find out what the exact version of the product, because that's obviously not true. But maybe Windows 10 and Windows Server 2016 have very similar TCP IP stack, and that's why it's being mapped this way. Notice the source is firepower, which means the source of that information is firepower, the passive scan. And also we see the applications. So FireAmp, okay, so maybe the FireAmp client is there. I believe it's there. Adobe Analytics in the background, SSL client, so over SSL trying to send some data out. Yeah, the web application CNN.com, because we were using client application Firefox 74 version to reach out to the CNN.com, and that's the web application actually that we can also discover. Cisco application, Google, Mozilla, for just for SSL client, because that's based on the HTTPS. OCSP, so also the Firefox was using OCSP to check out for the revocation of the certificates. That's why we have that mapped. Okay, and we have some attributes. There is one attribute that is host criticality. This is kind of label that we can, as administrators, we can add to the host. We can add other attributes if you like. Protocols, that's obvious. Okay. And where are my vulnerabilities? See them. 320 is the Active Directory server and DNS, so probably gonna be some information about see, the operating system is still pending because not enough packets went through. I don't see the vulnerabilities here. What? Let me change the switch back to the classic theme. Because it should be mapped here, and I don't see that. Maybe that's the problem with this experimental theme. Back to the employee PC. Yeah, that's strange. I don't see, there should be vulnerabilities mapped here. Let me check if I have vulnerabilities here. The VDB, but it should be in the product anyways. Even if it's old one, should be there. Okay, so I see two, both related to that 20. To that 20? To that 20 is the FMC itself. that's funny. Yeah, see the vulnerabilities? So something's wrong here. Okay, I think I need to get rid of this QoS policy real quick, and it's not allowing me to send any useful traffic. I can get rid of that. Okay, news. I need to go to the policy assignments and unassign it. They're gonna be QoS policy on the FMC, but not assigned to anything. Okay, once it's doing this, let's check the updates under the system updates. Maybe there is something new. No, nothing new in the vulnerabilities. Okay, also I need to check out the access control policy, because if I'm blocking something, there are gonna be no network discovery. Oh, sorry, I clicked the wrong icon. Okay, so my HTTP traffic should hit the first rule. HTTPS traffic should hit the default action. Okay, that's okay. For default action, I have logging enabled. That's also cool. Yeah, backup, that's only for destination DMZ server, and as the block is a different network. Okay. So that shouldn't affect my HTTP traffic. Now it's faster. Everything is over HTTPS nowadays, so it's let me check if I see anything in the connection events regarding this traffic. Yes, I see the host 9101 that is connecting out to different things, right? It's connecting to over HTTPS. And notice that next to the IP address, I have this icon, or host icon. All right, this host icon is blue now, which means this host is not affected by any security related security event. If it's grayed out, that means I don't have host profile for this IP address. Right? You can easily guess why I don't have host profiles for those hosts on the responder IP column, because they are all public IP addresses. Right? So I don't have them included in my network discovery policy, which is good, which is perfect. I don't want them to be in my database. And by the way, if you click this icon, not the IP address, the icon itself, it's gonna pop up a host profile window. You can easily check what is the host profile for, right? What is the operating system? What is the application? What are the applications? Why I don't see vulnerabilities? That's the why it looks like there are no vulnerabilities for that host. Probably because this version. Let me change the operating system manually. I will overwrite that and say this is Windows 10. Maybe there are no official vulnerabilities for server 2016. the Windows 10? Let me check. Now notice the source is the user admin, so I changed that manually. If it's gonna be better if I do user defined and I said, okay, that's the Microsoft. Windows. Yeah, so it looks like there are no. Yeah, so there are no updates for that one. Okay, I need to check that one. Windows and this way. Finish. There's a question in the chat. How can you extract this host profile data? You mean you would like to have a kind of report on that? You can do that with reports. You cannot simply, okay, or via APIs. Yeah, you can use APIs to do that. Oh, here we go. Now, see, when I change the product to Windows 10, it's now mapped 151 vulnerabilities to the component Windows 10. So now we have those vulnerabilities mapped. With analysis here, there are a couple of other options to look at the same data from a different perspective. So network map is obvious because you're looking at the network map. So you're searching for a specific IP address or looking into a specific subnet, right? So you have that easy to read or go through structure of the subnetting structure. Network devices. This is a category to show you only the network devices, not hosts. Okay, so if the type in the network, if the host profile is not host but network device, you can select to see only network devices. Talking about this field here, host type. If it says network device, that's going to be network device, or the switch or load balancer or something like that. Mobile devices, if you see here mobile device, then you're going to see mobile devices in this view. We don't see that now because we don't have any mobile devices, I believe. Let me click that and see. So Quais is asking, is this vulnerability mapping there even if the host is fully patched? Yes, because we don't know what is the patch level, because this is just the passive scan. We see from the packets what's on the host, and that's it. So that's why it's a potential. I always say that this is a potential, this is a list of potential vulnerabilities on the host, right? Because we never sure if the vulnerability is there, but at least we have that information that it might be there. If you want to have a very, clear or real information, then you need to integrate
FMC with a third-party vulnerability scanner. No, ThreatGrid is not a vulnerability scanner. ThreatGrid is the sandbox. Vulnerability scanners like Qualys or Nessus. Right? Those are scanners that are scanning hosts for vulnerabilities, and they know exactly what is the operating system, what is the patch level, what is the current vulnerability on that particular host. And then you can inject that information to the FMC. Okay? But this injection is basically this third-party software needs to connect via API to the FMC and inject that data into the FMC's database directly. Yeah, Rapid7 is the Nessus, right? So that's the same. Oh, Rapid7 is, I think so. Isn't that the same thing? Ah, okay, yeah, Tenable. Yeah, I agree. Yes. Yeah. So no, actually, you can. It's because it's up to the third party to inject that information. It's not that you need to support something on the FMC. On the FMC, the configuration to do that on the FMC is just the one thing. You need to go to the system integration. And add something called host input client. You basically create a client, for example, this Nessus or Rapid7, give it a IP address and a password that this client will be using to inject data, and everything else is on the client's side. There are usually some scripts, delivered by the third parties to inject that traffic. So it's unrelated. What is the third party product? Okay. Yeah, then you can see the same information, from a different angle again, based on the applications, application details, servers. If you are looking for something specific, you can find out, or based on the vulnerabilities. For example, you are looking for a specific vulnerability. There is a new vulnerability out there. You know CVE number, and you would like to check if you have any host that has that vulnerability in your network. So you go to vulnerabilities and then search through the host profiles, but based on a vulnerability as a key to search for. Yeah, absolutely. This is a really powerful system if you know how to use it. Yeah. Right. So we have those vulnerabilities. Uh, this Yeah, as I said, guys, to be true, be honest, Cisco Firepower lost a momentum a little bit because of those problems after acquiring the source fire, and the problem was because of the scale. So they never were prepared for a bigger or a big scale like this. Now they need to deal with a much bigger clients that than it was in a source fire times, and that was the problem. But now from 6.4 onwards, they are really kicking ass, and they are adding features. Now they get back on track with adding features, with migrating features from the ASA to the firepower, and it's really getting very powerful tool. Not only just a firewall, but a really advanced tool for threats mitigation, and all that stuff. Even yeah, okay. So that's for reliability. It's I think it's very reliable, especially if you have clustering, if you have um, failover at least. The only thing that I don't put trust on in this product is the URL filtering. Sorry, I will be telling you that one all the time. URL filtering, for me, not really reliable. Still, maybe it's gonna be better now when Cisco changed the vulnerability, the URL categories from the Bright Cloud to this to use the Cisco feed. Okay. Yeah, so you got in a good good place. You're gonna know what this box can do for you. I mean there. Mhm. Okay. The next thing, so we started talking about now about security features. So far, it was all about connectivity, right? Access control policy is the connectivity. The pre-filter is the connectivity. Host profiles, obviously, that's the things that we're gonna use later in the class for tune our IPS policies. But everything that we covered so far is more about connectivity rather than security. Okay? So now let's take a look at the security feature, which is one of the first in line when we talk about our traffic flow, which is the security intelligence. I will go to the preprocessors next week because preprocessors requires you to understand IPS first. Okay, so we're gonna talk about IPS and advanced IPS, which is the preprocessors. But first off, we're gonna start talking about security intelligence here and here. Those two things. Call it SI for short. Okay, so security intelligence is, everybody knows that as a IP blacklist. It was like that in version 5.4 and below, because in that version and below versions, we only had IP blacklists available. Now from actually from 6.0 and above, the product has three type of blacklists: IP, URL, and DNS. Okay? And we're going to talk about all of them. So again, if it comes to the packet processing, we go to the preprocessors, we go to the security intelligence first, then SSL decryption optionally, and we have security intelligence again, and then the access control policy. Right? So the first security intelligence is based on IP. This security intelligence is the URL and DNS based. Okay? So that's obvious because you first need to, sometimes you need to first decrypt SSL in order to see something in the packet. So that's why we have it in two different places. And the access control policy is here. And notice that this is very important. Security intelligence comes before access control policy, which means it can drop the packet before it even hits a rule in access control policy. You need to be aware of that. Now, what are the types of blacklists? Or, okay, types or sources. What can be a source of your blacklist? The obvious source is the Cisco. Cisco provides something called an intelligence feed. Cisco intelligence feed. That's the blacklist downloaded from Cisco Talos. Okay. Download from. Right. So Talos, as I said last week, this is that team of vulnerability, researchers and guys who are, monitoring and seeing that feed, the telemetry from all over the world, from Cisco customers and not only, and they are creating that feed. They know that at this moment there is something happening in China or it's something happening in Brazil, and they know what are the associated IP addresses, and they put those IP addresses on a blacklist. And you can download that IP address or that blacklist from Cisco. Actually, the minimum time to download it is 5 minutes for IP blacklists, because it's 30 minutes by default for other blacklists. 30 minutes for URL and DNS. So they are not being updated so frequently, but 5 minutes for IP. So think about that. Something happening in Brazil now, and you know about it in 5 minutes from now, and you have it on a blacklist, and you are protected. Okay? So it doesn't really matter if this is the source or destination. So if someone from that IP address, which is on the blacklist, is attacking you, the security intelligence will block that. If you or your client or your user in this case is opening a website and this is a destination IP address which is on the blacklist, that's going to be also blocked. Okay? So it doesn't need to be a website, might be a CNC, command and control server, for a malware infected host. Okay? So that's very important. Obviously, very important for firepower that is running on the internet edge. Okay? Because if it's running on a data center, maybe that's not so useful anymore, because on that blacklist, you only have public IP addresses. So it's useless if your data center will never see that IP address. Okay? But you can still use different blacklists because there are two other options. Second option, you can create custom. Right? Custom. And custom has two flavors. It can be a feed or it can be a list. Feed means this is a URL to a text file to be downloaded. For example, some customers have some CMs, right? Some automatic systems that are analyzing their network posture, and that CM has a capability of putting a list of bad IP addresses that this CM thinks that should be blocked. And this list can be saved on maybe on a HTTP server in your organization. So you can configure a custom blacklist on FMC with a type of feed to point to that URL, to that server, and download this text file with IP addresses in it to be blocked. Okay? List is just a text file that you can upload with IP addresses to be uploaded. You manually upload a list of IP addresses. It can be an IP address, like individual IP address, one IP address, or you can use CIDR blocks, like saying 1110/24. And third is something called a global blacklist. And a global blacklist is a blacklist that is always applied, not always, because you can actually unapply it, but if it's by default, it is applied to a sensor, to an FTD device. And the only way to add something to that blacklist is to use option in the logs. For example, whenever you are in a log, and whenever in the log you see IP address, you can right-click on that IP address, and then let's say this guy is, for example, I see this guy is doing something wrong. I right-click on that IP address, and I have option blacklist IP now, which means this IP address will be added to the global blacklist. It will be automatically sent to the device for blocking straight away. Okay? So there is no other way to add something to that global blacklist rather than using this blacklist IP. Blacklist IP now. So it's blacklist IP now option in event viewer. Okay, and a very important thing about this, when you do blacklist IP now, you don't need to redeploy. You just this IP address is going straight to the device, and it's being blocked. This is a cool thing. So it's being applied to a device without deploy. Okay. This blacklist, global blacklist. Now, by default, only the global blacklist is applied to the device. Let me show you that. So almost everything must be first applied to the access control policy in order to be applied to a device, right? So I go to the access control policy I have, and I have a security intelligence tab where I can apply different security intelligence categories. And notice by default, okay, on the left here, this is what I can apply. And this is on the right, there is where I can apply. Okay, so for example, whitelist, there's a section for whitelist and blacklist, because whitelisting is always also possible. But we talked about blacklist. So notice the blacklist for networks by default has global blacklist applied. Yeah, I can get rid of that if I want to, but usually don't want to do that. Right? So the global blacklist is already applied. But if you want to apply other blacklists, like Cisco provided blacklists, for example, you need to go on the left to the available objects, and those blacklists from attackers up to Tor exit node, those are the default Cisco provided blacklists. Default, yeah. The names of the blacklists from Cisco. If you click add to blacklist, that's gonna add all those categories. If I want to see how many IP addresses we have on those categories, if you hover your mouse on it for a second, notice that attackers currently have 7,912 IP addresses on it. Okay, CNC 29 IP addresses. Crypto mining 1,118 IP addresses. Okay, and so on. So, but you need to be careful because you must first apply them to a sensor this way, to apply them to the sensor by the access control policy first. And notice also that there is another option here, because all of them has this red X next to them, which means everything that is on this blacklist the packet will be dropped. But you can right click on that, and instead of block, you can choose to monitor only. Not block, but just monitor. Which, for a public blacklist, I don't think this is a good idea to monitor instead of blocking. But maybe you would like to have it to that option for your own blacklist, your custom blacklist. The question in the chat: once I update blacklist, does it update automatically when sync with Talos for a vulnerability discovered? Okay, so those blacklists have nothing to do with vulnerabilities, right? Those are just IP addresses that we consider bad. It should be blocked. And yes, it's done automatically. Once you first apply that blacklist to the sensor, when it comes to the update is going to be automatically applied to the sensor. Obviously, the update is being downloaded by the FMC, but it will be automatically applied to the sensor. So the new IP addresses will go to the sensor straight away. You don't need to redeploy anything, but you must have those categories applied first here on the blacklist, because otherwise they are not being applied. And I'm going to show you that, and I'm going to prove it. Let me go, guys, to to the FMC over CLI. Wrong, 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 wrong. Wrong PuTTY version. That's my FMC. Sometimes, actually very often, I hear a question, hey, is there a way to see what are the IP addresses in a specific category like the CNC? I would like to see those 29 IP addresses. Can I see them? And the answer is yes, you can, but you need to go to the CLI on the FMC, you go to the expert mode, and from the expert mode, you go to the following directory, var sf IP rep underscore download. This is the folder where FMC is downloading all the blacklists, IP blacklists. Okay, those are the individual blacklists. We have something called Sourcefire intelligence feed, which is the Cisco intelligence feed now. But once this is downloaded, it's gonna be stripped to a different, stripped to the different categories. If I do, let's say, more 60 something something, this file, hit enter. Notice this is the CNC, Cisco intelligence feed for CNC. So those are the 29 IP addresses that we saw, as a number in a GUI. But here we see the individual IP addresses now. And when I go to the FTD, FMC was there, FTD, I can do the same and go to the expert and check if I have those on the FTD on a device. And by default, we don't have them because they need to be first applied to the access control policy and then deployed for the first time. Having some issues with that device, I don't know why. There's something wrong with the server, a disk that this device is using. I can move it to a different disk and see during the lunch break. So when I go to the expert mode on the FTD, I can go to the same var sf IP rep, it's an IP repository download. If I do ls, notice that I have much less files. Actually, I have two of them, the C7 and D8. If you do more for those, you'll see that this is a global blacklist. Okay? So only the global blacklist is applied. Now when I go back to the GUI, I moved all individual categories from attackers to Tor exit node to the blacklist. Now I can save and deploy. And that's the access control policy change. So this deployment process will put those files
on the device here. I need to wait until it's over. We'll see that in a moment. So initially, when I assign those categories, blacklist categories to the device, they need to be copied from the FMC to the FTD. And later, when it comes an update for a specific blacklist from Cisco, this update will be automatically sent to the FTD. I don't need to deploy again. Also, notice where do we have those when we can configure updates. Let me show you that. It's under the objects. So blacklists are objects. If you go to object list on the FMC, we see here the security intelligence in 3 categories: network, DNS, and URL. We click network, which is about IP blacklist, and there is a Cisco intelligence feed, right? This is the feed from Cisco. You see when it was updated last time. If you want to manually update, you can click update feeds here. You can edit that and change the default update frequency, which is the default is 2 hours, but you can limit it to 5 minutes, which is really, or lower that to 5 minutes, not limit. Right, which is really cool. Every 5 minutes you have the new feed. Also, we have global blacklist and whitelist. If you click the blacklist, global blacklist, it's empty. And notice there is no way to add anything to that blacklist. This is because, as I said, the only way to add something to this blacklist is to use that option blacklist IP now. Right? So this is a nice feature. If you think that you are under attack or something is suspicious, you want to block a guy straight away, you can do that by simply right clicking on that IP address and do blacklist IP now. This 193 gonna be sent to the blacklist. So now when I go back to the objects, if I edit that global blacklist, I see this IP on the list. And I have only option to delete that from the list. By the way, when I go to the device and check for files, oh, now I have those files, but let me check the file I did more previously, which was the global blacklist, but it was empty right here. If I do that again, notice this IP address I just blacklisted is here. If I go back to the FMC and delete that from a blacklist, the FMC will go to the FTD and withdraw that IP in a second. So it takes usually a couple of seconds to get rid of that. There's a question in the chat. Can you block IP addresses coming from specific country from event tab? No. The only thing that you can do is the geolocation, and you can create a rule to block based on the geolocation. But you cannot use geolocation for security intelligence. Okay, see, now it's empty again. If I do more, 60 something, that's the more or not mode. or that's the CNC. That's exactly the same feed that I had in on the manager. Now when let me check if that works. So click connect to the employee PC, and I will try to send a packet to one of those IP addresses from the CNC blacklist. Okay, so just to just ping maybe, I don't know, the second one, 58 171 3826. Okay, so ping doesn't seem it doesn't work. Okay, now if I go to my, those are the connection events. If I click this pause icon and click again this play icon, that's gonna refresh the page. You don't need to refresh the page with a refresh button in the web browser. It's faster when you do that this way. You click this pause and then play. So notice here, amongst other connections I see the one that is blocked, and the reason is IP block. That was blocked based on security intelligence. I know that this is because the reason is saying IP block. I know that this is the IP blacklist. There is a specific log for security intelligence events, specific place here. So I don't want to see all connections. I want to see specific security events. This time security intelligence events. So I should see that this only one event here. Let me go to that event. Right, the action was blocked based on IP block. That was my host. The responder was the IP address I was pinging. It's in Australia. And notice that the security intelligence category was CNC. If I see something like this in my security intelligence log, I know that this guy is malware infected for sure, because his host tries to reach out to the CNC. So we need to take care of that. And notice the change of the color of this host icon next to the IP address. It's now red. It's now red because this host profile has a security event on it, or we call it indication of compromise. The indication of compromise, now we see CNC connected. This indication compromise is causing that this icon is no longer blue, is now red, because that's something that happened to that IP address, that host. What we can do here to get rid of this color, we need to manually resolve that. Yeah, so for example, I called service desk, or people respond, people that are taking care of hosts and their operating systems, and I requested them to go there and maybe reinstall the system, to be clear. And then I got a response from them that, okay, now system is cleared, everything is fine. Okay, so I can go back here and delete this indication of compromise. I deleted that from the host profile, right? And now when I refresh that, right, the color is back blue. Okay? Obviously, the event is still there, but color is now blue. Okay.
What else? Under here, under the objects, you can create your own network list or feed. So depending on what you would like to achieve, you can choose feed or list. So feed is that URL. You need to provide URL to the text file that you can fetch from a server and use it, or you can just provide a list. Right? My blacklist, let's call it a list of IP addresses. Do I have any? Probably I have some. Yeah, so I have IP text file upload. Three IP addresses. Let me show you that. That text file here. 10.1.1.1 CIDR block for 20/24 and some individual IP address. So it was taken as a 3 separate IP addresses. Okay? 3. Even though there is more than 3 IP addresses because the CIDR block is /24. Okay? So now I created my own blacklist, but it's not going to be automatically assigned or applied to the device. I need to go to the access control policy and on a security intelligence tab, I need to apply it. Intelligence. Now I should see my list on access here. I can optionally choose not to block, but maybe monitor instead of block. So that's for IP. What about URL? Similar thing. When you go to the objects first, there is the URL lists. Being downloaded at the same time. So it must be configured here under the DNS list and feeds. Notice that there is a Cisco DNS and URL intelligence feed. We can change the update frequency from 2 hours to 30 minutes. And also we have global blacklists. If we click in a logs, somewhere in a log, a URL, then we can choose to block the whole domain or the whole URL. We can also add our own again feed or list. Okay, but none of these gonna be working unless again we go to the access control policy security intelligence tab. And now we click URLs here from available objects. And the same is here, the URL attackers, URL Tor exit node, and we click add to blacklist. Notice that underneath here on the list, there is another section for URLs. And those are the URL blacklists that must be gonna be applied to the device, right? So again, save and deploy to see them on a device. Yeah, just that's why I haven't blocked it. I'm just monitoring it. So we'll see if that works. By the way, if you are interested where this URL feed is, or you would like to see the URLs that are going to be blocked by the blacklist, there is another useful place to go.
which is called SI URL download. It's a var sf SI URL. Okay, and the same thing, if you do more, and we see, even though we see at the beginning, we see some IP addresses, okay, later we will see, you know, domains, all the whole URLs. Let me go down a bit. As you can see, those are the regenerated by using the most likely the domain generation algorithm. Just wanted to show you that this is not just the host name part, but also the whole URL, like, you know, backslash something something. Oh my God, money. Okay, maybe in a different one. Okay, nothing here. URL bots, one only. Crypto mining, lots of. Okay, anyway, I don't want to spend the whole day and going through this. Yeah. Okay. So obviously the same folder is on a device on the FTD. It's freezing. I don't know what's going on here. SI URL, and you can check, right, if you have those files, because without the first deployment, you will not have this those files here. Okay. Right. So if we go, okay, let's try one of these. Again, go to my employee PC. What's going on here? Oh, thanks for link, Raminder. Useful stuff. Okay, let's try to connect to something like this. www1 epool.io. Okay, so it's not working. By the way, let me ping that 1111. That's working, even though I have it on a blacklist, but my blacklist is set to not block, to monitor. Now when I go back to logs, when I refresh my security intelligence events, I should see two more events. One for URL blocking, one for IP monitoring. I don't see the URL one. IP monitor is here. Notice that this 1111, my blacklist was set to not block, to monitor only. That's why the reason is saying IP monitor. Okay, why I don't see the URL? Might be because it's not valid anymore. Let's check if I can resolve the name. What was the name of the pool IO? I can even ping it. But obviously ping is not the URL. I'm trying to send. Might be the problem that it's not listening on port 80. Let me do this. And do I have a telnet? No. Party. No, nothing. Probably this is not working host. I mean, not working on port 80. Let's do something next. BC, KC, or maybe there's Philly. That's Philly.cc. Just easier to, faster to type in Philly.cc. Still not. Okay, anyways, I don't want to spend time on that. Let's give it a time. And what time is it? Okay, guys. So I think, what do you think about having a lunch break now? That's not the end. Talking me about security intelligence. I have another thing, very important thing to cover. I want to spend some time talking about how the malware infection happens. That's going to be very interesting and important for cover and give you some information about DNS, why DNS blacklist is so important. What is the DNS sinkholing? That's also going to be important for AMP. Understand how AMP can help us to not get infected. Right. So the next topic is also important, but it's quite extensive. So let's take a lunch break maybe now, and we're gonna continue with security intelligence after lunch. 30 as always. Okay, so see you guys in 30. Have a nice lunch. Guys, let's continue, and let's talk about security intelligence related to the DNS. Before I go into the security intelligence DNS configuration, I would like to talk a little bit more about how malware infection can happen. So how it is how is it actually getting infected? So how does malware Okay, so we have an obvious scenario, FTD connecting us to the internet. Here is our user with his host. Right, and so what is the most common scenario for infection? Let's say this user is opening a website. This might be a legitimate normal website, or something that website might be infected as well, or it's a kind of not really legal website, like maybe a website with some software cracks, or some things like that. And this website is opening a pop-up, right? It might be a pop-up, or might be even an iframe, which is connecting to another server, but it's not visible to the end user. So the user doesn't see that he's like opening another connection to another website. This pop-up, for example, can direct or open another connection to something called an exploit kit, to the website or to the server with an exploit kit. Exploit kit, as name implies, is a set of exploits, specially crafted to a server to try different exploits on our system, right? Because it's really highly unlikely when when everybody gets infected with the same exploit, infected by the same malware, but using the same exploit or exploitation method. Each user and each host is different. It might be Windows 7, it might be Windows 10, it might be this patch level or that patch level. It might have a different software or vulnerable software installed, or vulnerability in a web browser. So depending on this host, the exploit kit is trying to exploit different things. Okay, so exploit kit tries to exploit, for example, a web browser a vulnerability in a web browser, in an operating system itself, in some applications like supporting applications like Java or Flash or Silverlight, right? Things like that. So it doesn't necessarily need to be a vulnerability in the web browser itself. It might be a vulnerability with some supporting software to the browser, right? So the exploit kit is exploiting that vulnerability or tries different exploits. And once the exploit exploits the vulnerability, the reason for or the goal is to inject and execute a code. Or let's say malware code. Okay, what is that code? We call this a dropper. It's usually a kind of executable piece of code. I'm especially not saying this is executable file because it's usually not a file. It's just a code that can be executed by its parent, and the parent is what is being exploited. Like for example, Java. If you use Java and the Java is vulnerable, a piece of code is getting injected into the Java process, and the Java process can create a file and put this file on a disk. This is a dropper file. This is the initial infection. It's not really bad yet. It's not end of the world, because the dropper itself, the initial infection, is not doing anything except just putting a piece of code on your disk. Okay, what will be the next step? The next step will be to connect out to the internet and find out something called a CNC, or C2, we call it now today. CNC, right? It's a command and control server. So this piece of malware, must to find out and connect to the CNC. Now this is the problem now, because we need to find out where the CNC is located at the moment. So obviously, not the CNC or exploit kit. It's not being hosted in those malicious guys or bad guys at home. No, they are just using some publicly available service providers that they are just buying services from the service provider and installing on that web server or some virtual server exploit kit and CNC. So you're connecting to the legitimate IP address. Okay? The problem is that for malware is to how to find the CNC, because it's difficult sometimes, because if you embed something into the malware code, that IP address will be on all security intelligence feeds or blacklists in the world in a couple of minutes. So that's not the way to do, right? We need to find another way to find out the IP address for the CNC. So let me step back a little bit. So what are the, let's say, bad guys dilemma? First is how to exploit, how to infect, do the initial infection, how to really redirect the client to the exploit kit. Redirect or point to, or point a user to the exploit kit. That's the first problem. And obviously, one of the options here is a pop-up, maybe a phishing email, right? So or spam. So, for example, a user gets an email saying, "Oh, here is a nice video about some, something nice, right? Like funny kitten." And this user is clicking this link, and this link can direct him to the website when, he or she can even see that video, that funny video, but there is a pop-up opened that directs the user to the exploit kit. So that's another very popular method to do that. And you may say, yeah, but I'm not opening such emails. I'm deleting them straight away. I'm not clicking any links. I'm not going or surfing any bad websites. Like I'm not going to the porn, to cracks and stuff like that. So I should be good, right? Not necessarily, because at least a couple of weeks. No, I think it was a year ago or even more now. Time flies by so fast. Cisco actually found Cisco researchers found a new category of of or new way of infection, which was basically the angler. It was using advertisements, and they call it a malvertisement. Malvertisement. So they found that there are not a lot, but there are some legitimate websites out there. It was at this specific scenario, it was New York Times and ESPN websites, infected with some malware malware ads. So even if the website itself is legitimate, is trusted, the advertisement that you see on that website may not be, because when they are pretend to be a regular or normal users to the advertisement companies like the Google AdWords or to other advertisement companies that do the ads campaigns, and they buy that campaign with some real money. It's usually some stolen credit card used to pay for that, but anyway, this is a real money for, and it's hard to differentiate a bad guy who's buying this advert campaign from a regular or good guy who's doing this. So yeah, so a lot of people get infected by clicking on those websites in the ads, right? So it's not that obvious that if you are not going to any bad sites or suspicious sites, you will not get infected, right? So that's the first dilemma of the bad guys. Second one is once you have that dropper and malware infected host, is how to reach to the CNC. Okay, and so as I said, if IP is not a good idea embedded in the code, because this IP can be easily stopped. This connection can be easily stopped by the security intelligence based on the IP blacklist. Right? Okay, so maybe a name, right? Or FQDN. Let's go with FQDN. If you say if you put FQDN, that's going to be similar situation, because as FQDN must first be resolved to the IP. So IP still can be blacklisted, or you can use URL blacklist in security intelligence to catch that connection. And finally, they may use something called a DGA. DGA stands for Domain Generation Algorithm. So it's a way to generate a domain like something like this: x7ba8c6.cn, right? Something like that. So for us, it looks like something not right, okay? Something generated. For security systems, for any systems, it's not really there is no difference between something like that and a real name. But they're using this algorithm to generate domain, and then based on regular DNS service out there, this domain can be resolved to the valid IP address. So by the way, it's really hard, as I said, for service providers to find that somebody is running CNC in their environment. Right? They see that based on the traffic that is going to, and based on some reporting, abuse reporting by different researchers. Maybe the Cisco Talos is investigating something, and they know that, okay, those are the exploit kits on those IP addresses. Here are a couple of CNCs on those IP addresses, and they report that to the service provider, and the service provider takes those IPs down. So, by the way, an average lifetime for the CNC for a command and control server is 1 day. So it's really dynamic. It's really hard to do something like FQDN or IP because it's too dynamic. And DGA is a perfect solution for that. So how does it work? Basically, the same algorithm is used by this malware code and something here at the CNC. So they are using some algorithm to generate or pre-generate maybe 1,000 domains like this. And they registered those domains in a DNS. Okay, so once the malware is generating this domain, it will ask for a domain. We will not have it in a URL blacklist most likely because it was just generated, and it's gonna find using the public DNS the IP address of the running CNC. So that's the most challenging thing to stop today. Obviously, if some researcher, like again Cisco Talos guys, they have some samples of a malware. If they get that sample, they can do reverse engineering of the code, and then they can understand what is the domain generation algorithm used. So they can, using this algorithm, they can generate those 1,000 domains, and they put those domains on a blacklist. So this is what we saw in the lab, and we're checking the yeah, for a URL we're checking this one. So all those here that EU, all those domains are generated with some algorithm. Yeah, exactly. Thanks, Niket, for the link. Yes, the blog on the Talos Intelligence is really cool resource, and you can find a lot of useful information there, not only about the latest threats, but also how to prevent and what this our solution, the firepower solution, can do to help you protect. Right. So now we have a problem. Now we have a problem when the malware code can reach out to the CNC, because now CNC can give this code orders. Okay. Number 3 in this bad guy's dilemma is what to do with this infected host. Right? And what we can do, obviously very popular today, we can encrypt files and ask for a ransom. Right? So that's the ransomware. What else? We can start Bitcoin mining, crypto mining. What else? We can steal some passwords and use them to hack into the machine or something like that. Password stealing. We can do espionage. We can do some, I don't know, document leaking. Right? Or we can use this host as a typical zombie host that's gonna be waiting for our sign to attack. Right? If you want to do some DDoS, denial of service, distributed denial of service attack, then this host is not doing anything. It's just waiting for an order for an attack. Right. So you're making a botnet. Botnet is basically a network of infected hosts under a control of a CNC server. Okay. So yeah, so there are a lot of options here. So once the malware is connecting to the CNC tells the malware what to do, and the malware should actually and get additional content. For example, if this malware gets information, okay, you should encrypt files. This malware, this code is too small, it's not capable of encrypting files, because that was just a dropper, the initial infection. It must get some additional payload, some additional files to start encrypting our data. Okay, so once we get that order, this is a difficult situation now. Okay, so the initial infection is not the end of the world. The end of the world is when you allow this malware to connect to the CNC, get an order, and download some additional payloads to do some bad things. Okay, so now notice about this DGA again, how we can handle that. The DNS blacklist is something that can help you, because we not only can block based on IP, we can block based on the DNS query, right? So the malware tries to resolve that name, and the DNS blacklist can have that name and respond to the malware process. Okay, so with a DNS, it's a little bit more complicated than you may think of. Let's say DNS security intelligence behavior. We have FTD, internet, and a host. Okay, the problem with a DNS is that it's relying on a DNS infrastructure, and we have that DNS infrastructure usually on our side. So we have some internal DNS, and we also have external DNS. Right? That's the internal. So if the host gets infected, it's infected host, it's using DGA to generate that strange looking domain. So it's start asking about that domain, right? Who is, right, this X7AB and so on. Who is? The DNS has something called a recursive lookup. So this internal DNS that we are asking for that is solely responsible to give us the answer. Okay, so it's sending out this query asking who is this guy. Okay, if we have FTD and we have security intelligence enabled, we have security intelligence DNS enabled, and we have that domain on a DNS, we see this query and we respond instead of blocking. And that's a default behavior. We are sending NX domain back to the DNS. NX domain, it's a non-existing domain message. Okay, we are pretending we are intercepting this DNS query, and we are responding to the DNS with not existing domain message. So the DNS must get back to the host with the same information, and now the host knows, okay, there is no such domain. Why we trying to? Why we not blocking? Why we sending some answer? Because if that's the generated domain, if we respond with non-existing domain, there is a chance that this malware on the host will give up, right? Because it knows, okay, this domain doesn't exist. So maybe the DNS is broken. Maybe DNS is not configured for public, to resolve public IP names. Sorry, things like that. So there's a chance that the malware process will give up on checking. If we block that, then this guy will time out and then eventually create another query and another query and another query. So we don't want to have a lot of DNS, unnecessary DNS traffic this way. And this is a problem for new domains. No, because that domain would need to be on a DNS security intelligence feed that you download from Cisco. So it shouldn't be. If nobody puts that on a blacklist, then it's not a problem. Okay? But the problem is here in this scenario, in a default scenario, the problem is that if this host is asking the internal DNS and the internal DNS is trying to reach out to the external DNS to resolve that, the FTD, what FTD sees in the log? Who's asking? FTD is seeing the internal DNS that is asking about that domain. We don't know who is originally infected, because all the queries are coming from the internal DNS, right? So we know that we have some infected hosts because it's asking for such domains, but we don't know what the host, which host is infected, because this is the DNS that is asking, not the original host. That's why in DNS security, we have something called a SYN call. SYN call is, let me put that again. And this is internal DNS, this is external DNS, and CNC server here. Oh, I forgot to put CNC server. Okay, doesn't really matter. Right, so same scenario. We are asking infected host is asking for some domain, right? Who is this guy? Now, the internal DNS is trying to reach out to the external DNS to find it, right? But we have security intelligence for DNS, but instead of answering with a non-existing domain, we are answering with a SYN call IP. So it's like we resolve that query. This is basically a response to the internal DNS, and the internal DNS must send it to the host as an answer. And host says, oh, cool, I have that IP address of the CNC. Obviously, that's not the IP address of the CNC. The trick is we need to put that sync call somewhere behind the FTD, right? So the sync call server, it might be just a fake IP address. It doesn't even, it may not be existing IP address. The thing is that it must be in the network somewhere behind the FTD, let's say 10.2.2.5. Okay? So if we answer 10.2.2.5, we provide that IP address to the host. This infected host will try to reach out to this sync call, and the FTD is going to block it. And the thing is, going to have that in the log. So we know now who is infected, because everybody that trying to reach out to 10.2.2.5 to that sync call, those guys are infected. Okay? So the trick is to have a sync call IP set to the IP behind FTD. Even might be something public, or doesn't really matter. It might be non-existing IP address, but it must be routed to the FTD. And let me put that NX domain means not existing. Or domain not found, basically. Let me show you that in action. So first off, I go to the objects. Under the objects, we need to create a sync call. This is just an object that might be a fake, right? Let's call it my sync call. IP address, okay, must be behind the FTD. So in my case, that's gonna, okay, that might be something in a DMZ. So 172.16.1.99. Okay, I need to provide some IP address for IPv6. I said block and lock connections to the sync call. And then I'm going to configure DNS policy. Notice that this is not just the DNS objects similar to the network IP or URL that we just moved to the right here. There is a separate policy for DNS, and we can configure it directly from here when I click this this pencil icon next to it. I'm gonna open the DNS policy for me in a new tab. And by default, we have only global whitelist and global blacklist. Notice what is the action for global blacklist. Domain not found. Okay. So to make that work, I mean, based on security intelligence for DNS from Cisco, I need to add new DNS rule here. Let's call it Cisco DNS blacklist. And on a DNS, I select DNS attackers till DNS Tor exit node. problem with reason it doesn't work for me. This add to rule, and instead of saying domain not found, okay, I would like to send the sinkhole IP address as an answer. And here I need to select the sinkhole object that I just created. Add this. Now I can save. Okay, and I need to redeploy for the first time. See the DNS policy, deploy. And there is a separate directory for storing DNS security intelligence. It is under the SIDNS download. Oh, what is SI? Right. It's a var SF SIDNS download. Okay, if I do more, this is DNS and URL intelligence feed, DNS CNC. All those are considered a DNS name, so that this is gonna work for a DNS query. How can I check that? Obviously, on an FTD, I can go and do the same, but on my employee PC, I'm gonna be testing with ping. I should have a Wireshark here. Okay, still waiting for all those files to be on the FTD. Okay, I have them. Okay, let's use this one maybe. Okay, let me start Wireshark. Apply the filter for DNS and try to ping or resolve basically DHSCA COZA. Okay, I cannot ping it because I don't have IP address. Okay, let's see. That was the query. Okay, did we get a response here? We got no such name. Why we got no such name? Okay, by the way, it's a little bit difficult because I think I have the wrong DNS. Yeah, I have a DNS which is the open DNS on this host. So let me change that to the to use the internal DNS. Because the open DNS will it knows that this is a bad domain, so it will send back to me not existing domains. I don't want to rely on that. Let me use my DNS, internal DNS 10.10.3.20. I will flush the DNS cache. Okay, and again, I will try to ping for this domain. And notice what is the answer. This is the sinkhole IP address, right? Even though I was sending this query here to my internal DNS server 3.20, right? I got the response from this server, okay? And the response is the sinkhole's IP address. Okay, so DNS server tried to reach out to the external DNS server on the internet, and the FTD intercepted that and answered on behalf of that server, that external server, with a sinkhole IP. Right, in the logs, okay, in the log I see the sinkhole is the action, the reason DNS block. Notice the initiator IP is actually my DNS server, because that was the query, right? The DNS server is using 8888 as the Google's DNS as a forwarder. It was the security intelligence category DNS CNC. But in a connection events, I should see a connection to this sinkhole IP address. I see it here. This one. Oh, okay. This ICMP. Even if it says allow. Okay. It might be allowed, but yeah, it shouldn't be going there. to check if I have, and that's a regular traffic. Anyways, the easiest way to find out this is basically to search for who is connecting to this IP address. Everybody that are trying to connect to that IP address, they are infected. Okay. We have a time for as well. Do that. Okay, so the next topic, which is the last topic for today, is Cisco AMP. So now, once we know how the infection happens, we could possibly think about scenario that we are not allowing this guy to download this dropper even. Maybe we could stop this initial infection. Right? So remember, FTD is being managed by FMC. And when it comes to that dropper, right? So this is the exploit kit. And the dropper is going this way. We see, let's say the dropper is 100 packets. Right? The dropper. We are actually delivering almost all of those packets except the last one. 99 packets are delivered to the host, but not the last one. So the host cannot be infected because it doesn't have all the required packets. But FTD has all packets required to have a whole file and can do a hash of that file, SHA-256, and send that hash to the FMC asking for a disposition. So FMC must reach out to the internet, to the AMP cloud, to get disposition check. This is a disposition check. Process. The response for that process, it should be, there's an SLA, so below 200 milliseconds should be a response. Disposition for the file is one of those of the three: malware, clean, or unknown. Okay, so if that was the malware file and we know about it, the AMP cloud knows about it, the FMC will request FTD to drop that file, and most likely the FTD will send the TCP reset to the client, to the user, to get rid of that connection. So all those packets are being discarded. The file is being discarded too. Okay, so it's based on the hash. This, what we are talking here, is called AMP for networks. Okay, the AMP for networks is a connector or actually a kind of agent, let's call it, on the FTD, on the networking device. It can be FTD or WSA or ESA, in case of Cisco devices. And yeah, it's supposed to just take a hash out of the file and send it to the FMC, and through the FMC to the AMP cloud. But it's way more than this, because what is the difference between this and a typical anti-malware solution that you may have on the host? Yeah, if you have a local let's call it antivirus installed on a host, if this file, the dropper, is sent to the host or downloaded by the host, this antivirus local solution should also find it, right? Yes, and I agree. That's if this is a well-known thing, it should be found as well on the endpoint. But the problem is with a modern malware. Modern malware is actually, we call it zero-day malware. It's a little bit different zero-day that we know about maybe from, I don't know, 15 years ago. Okay, so 15 years ago or 20 years ago, there was a zero-day as well. So we were talking, if something is zero-day, that there is an attack, or there is a vulnerability that is being exploited, but we don't have a patch for it yet. Right? So that was the zero-day. Today, modern malware can morph itself. There is a polymorphism. Modern malware is polymorphic, which means it can change itself. It can change its code on the fly. For example, this dropper, right, can look like this, but infecting this host. Maybe another host next to this one is doing exactly the same, and this dropper affecting or infecting this host gonna be slightly different. And this is what we call zero-day now. Zero-day is everything that is changing that we see for the first time. And it's not a problem with 99% of cases. The problem is with this 1% of malware that is more advanced, that is really zero-day. Okay? Because there can be only one infection. If it comes to the ransomware, like WannaCry, for example, you're gonna get infection and you will be screwed all because of all your workstations gonna be infected, maybe some servers and all that stuff. So we need to take care, really, not about everything that is really known. We need to take care of this remaining 1% that might be causing a real problems. Okay, and this is something that a typical antivirus that you have on a workstation will not address, because of two things. One, local antivirus is always being updated, every couple of hours, days, or some time. So there might be something new, and you still don't have a signature for it. So it's not like a real time. you need to wait for the update. If you have 1,000 or 10,000 endpoints or 10,000 hosts in your network, the update must be downloaded 10,000 times. So that gives us a little bit of gap between a vulnerability and the protection. That's the first thing. Another thing is that the local antivirus or typical antivirus is always based on the signatures. I mean, on a pattern. So if we see the pattern in a file that is created on a disk, then we're gonna catch it, move it to the quarantine, something like that. But in case of a modern malware, the polymorphic malware, then this dropper can look completely different. And it is enough to change maybe 1-2 bytes in a dropper so that nothing that is anything that is pattern based will fail, right? With catching this type of malware. So we know today that typical antivirus, local antivirus solution on the endpoint is today is efficient in less than 30% if it comes to the modern malware. Okay. So this is the situation that this is the world that we live in. So I would like to give you some more information about what is happening within this cloud, right, in order to better understand what's going on and how difficult this solution is, how advanced it is. This is the AMP cloud. Right? This is the AMP cloud that we have here on the internet. So if this position check coming, right, with this hash, let's say, a simple thing, 256, it first hits a server with a database. We call it ProtectDB, and it's a big database with hashes and their dispositions. So for example, hash 1 is malware, hash 2 is clean, hash 3 is malware, and there are billions of those hashes today in this ProtectDB. Right? Now, this ProtectDB is to protect you against that 99% of cases, I would say. Okay? It's very similar to the protection of a local antivirus, because a local antivirus is based on a pattern. This disposition check and ProtectDB is based on the hash. So it's very similar. The only advantage against the regular local antivirus is that this is the online, and we have always access to the latest and greatest information. Okay, so we are not waiting for any signatures to be installed. We just asking and we get the response. But if it comes to the efficiency, I would say it's quite similar, because if it comes to the modern malware and the polymorphism of it, it still be failing. So local antivirus will be failing because it will not find the pattern. And AMP will gonna fail again because the hash will be different. Right? for the file. But I would like to give you some more information what's going on in the cloud, because this is not the only thing that we have there. There are a couple of other options that are very advanced and will give you a nice overview, an insight what's going on there. So in case of AMP, there is also another engine that you can enable even on the FTD. Okay? Hash is just the default. You don't even need to configure that specifically. But if you want to, you can add some additional engines or enable some additional engines on the FTD. One of those engines is Spiro. Okay? Spiro is working only for Microsoft executable files. So MS exe. Right? Microsoft executable files. What it does, it gathers attributes of that file without detonating or running this file. Okay? There are currently more than 400 attributes that can be gathered. And based on those attributes, it populates kind of array of attributes. We call this array a file fingerprint. Okay? So if some attribute is there, it sets 1 in that file fingerprint. If it's not there, it sets 0. Okay? So maybe we had something like that. What are the attributes? For example, simple things like what we see in a file header. What is the file version? What is the file compiler? What is the file or libraries that the file is using? What is the system calls that the file is trying to, or not trying, but is configured to use, and so on. So there are many different attributes that we can gather with, again, without running this file, because we don't run executable file on the FTD, right? We're just analyzing this file and send that Spiro, so we can add that Spiro fingerprint to this position check. Okay? Now we have two information, SHA-256 and Spiro file fingerprint. Okay? And inside the cloud, there is a Spiro engine, and the Spiro engine is comparing our file's fingerprint, okay, with a known malware fingerprint. Okay. And a known malware may have something like this. Okay. So it checks. Okay, that's the same. This is different. That's the same. Okay, so it judges like maybe, I don't know, 71%. It has some attributes. It has attributes like a known malware. So it's usually not 0, 1, 100%. um, sure. It's like estimation. Okay, we are comparing our file's attributes to the known malware attributes, and we know that it looks like it has some attributes like a real malware. Okay, there's additional another useful engine in the cloud called Ethos. Ethos actually Ethos cannot be running on the FTD. Remember, we have two amps. We have amp for networks, or we can have amp for endpoints. Right? So the same connector, but it can run on a network device, or it can run on the endpoint, on a host. Okay, not all features the same on both. For example, Ethos can be enabled on AMP for endpoints, but cannot be enabled on AMP for networks. And you will understand why in a second. What Ethos does. Ethos is doing something called a fuzzy fingerprinting. Fuzzy fingerprinting is okay. Let me ask you a question, guys. What if I'm doing a hash of a file, right? If I change one bit in that file and do the hash again, will this hash, the new hash, will this hash be comparable to the previous hash, or it will be completely different? Will it be similar to the previous, or will be the completely different? If I change one bit in a file, yeah, it's gonna be different. It's gonna be completely different. It's even not, remotely similar. It's completely different. Another quick question. If I change the file name and do the hash again, will the file hash be different, completely different, or the same? Yes, very good. Same. So name of the file is not affecting the hash, because hash is done from the payload, not from the name, right? Exactly. So if it comes to the malware that is polymorphic, right? It can change itself, like changing one bit or byte in a code. Okay. Maybe instead of making one hash of the file, obviously, if this is a polymorphic malware, we're gonna get different hashes each time we do that. Okay? So we'll not find anything in the protect DB because this hash is completely different. What about instead of doing one hash, what about if we cut this file or slice this file to multiple chunks, and we do different and we create hashes, individual hashes for those chunks, right? This is the fuzzy fingerprinting. Now, if we do this and we send that information to the AMP cloud, the Ethos running in the AMP cloud gonna compare our file or our file hashes with a known malware hashes. okay? And we'll check, okay, this is the same, this is the same, this is different, this is the same. So now we know that this file was completely, it was almost the same file. This is just one hash, one piece of that file is different. Okay? So ethos is really nice to find that the polymorphic malware and find what is the family of that malware. Okay? And again, can give us some clue, like saying, okay, in 65% it looks like a known malware. Question in the chat: can AMP Cloud not run the malware in a sandbox and collect all the info? It can, yes, but it's not in the cloud, in the AMP Cloud. We'll talk about this in a second. Yeah. Okay, so notice, now you know, most probably, why Ethos is not available on AMP for networks. Because it may be too overwhelming for a networking device to compute multiple hashes for one file instead of one hash, right? That's why Ethos is only available for AMP for endpoints, because we can give a little bit more, CPU cycles to that process. Okay, there must be something here in the cloud that will make an ultimate decision for us, because the disposition can be malware clean or unknown. Right? So there is a process called business logic layer that will take information from Spiro, Ethos, will also consider different things. For example, let me put a couple of them here. Dropkick. That's quite important. The dropkick is the information about the parent of that file. And as you probably know, there are better and not that good parents. So in this case, if this dropper, because let's say we are exploited Java process, and this dropper is being created by the Java is really, really bad parent, right? So if a file is created by Java, right, we know that, and we give that information to business logic layer, so that the ultimate decision can be more, it can be adjusted because of that, because this particular event was created by the bad parent. Java, what else? Flash, Adobe Reader. So if Adobe Reader is creating executable file, that's something suspicious, right? Adobe Reader can create temporary PDF file, but not executable file. So the dropkick will give us some additional info. Same with something called a low prevalence. Low prevalence is a process that will give us information about how popular the file is. Okay, the thing is that if we have a less popular file, so let's say we see that file for the very first time worldwide, okay, the AMP Cloud never seen that file before, there is an increased chance that this file is a 0-day polymorphic file. Okay, so if file is less popular or not popular at all, only one copy of that file worldwide, then it's increasing the chance for this file to be a malware. So based on all that things, the business logic layer makes a decision and send it to back to the FMC in that case. Okay, and finally, another thing is dynamic analysis. Dynamic analysis is another just checkbox that we can enable, and dynamic analysis means send the file to the sandbox. And by the way, this is one of the reason, also one of the situation when the file is directly sent from FTD to the internet. It's not being sent to the FMC. Okay? Because normally only the FMC is connecting to the AMP cloud and asking for a disposition. In case of dynamic analysis, FTD itself sending the file out to the cloud. So this is one of the situation when the FTD must have access, direct access to the internet through, by the way, through the management interface. We cannot use this outside interface to send that file out. No, we need to go through the management interface. Okay, so if we decided to send it to the sandbox, right, this file is sent to the sandbox through the AMP cloud. Okay, so here we have dynamic analysis. And now this is not the AMP cloud that is doing the sandbox. There is another cloud, right, called RedGrid. RedGrid. Okay, that's the sandbox. But AMP cloud talks to ThreadGrid via APIs internally. So if you send the file to dynamic analysis, you're sending it to the AMP cloud, but basically AMP cloud send it to the ThreadGrid. So once the sandboxing is done, the ThreadGrid send back the AMP cloud TG score for this sample, something between 1 and 100. That's a number. The higher number is, the more possible that the sample is the malware, and the report. Okay. Now the sandboxing technologies are very, I would say, very sophisticated, because what's the sandbox? Sandbox is just a virtual environment that you can spin off, right? A virtual machine, and you can inject the file, as we call it sample. You are injecting this file and detonating that file and looking what the file is doing. Okay? So this is actually the behavioral, or we are analyzing the behavior of that file in the sandbox. What the file is doing. Is it creating any other files? Is it changing some properties of the user? Is it disabling shadow copy on Windows? By the way, if something disabling shadow copy on Windows, 99% of cases this is a ransomware, okay? Because it doesn't want you to have a copy
and or backup of your files. What else? Checking if there are some entries in the registry. Checking if there are some connections to the outside world. Is it connecting to bad IP addresses that we have on the blacklist? All that stuff. So all those behaviors are being monitored, and finally we are guessing what the threat score will be. So the threat score is based on those behavioral indicators, individual indicators. Each indicator has some value up to 100, and then we give out the whole TG score for a whole sample. And modern malware, or not modern, but advanced malware can try to detect if it's being sandboxed or not. So that's actually the problem for guys who are creating sandboxes, because they sometimes can be easily detected. Okay, so for example, what the malware can check to detect if it's being detonated in a virtual environment. Things like if you see a VMware network card, that's a virtual environment, right? If you don't see a user, you don't see any mouse movements, you don't see the Office being installed or Office installed, you don't see some files, obvious files, you don't have internet connection, stuff like that. That gives a malware a reason to not detonate itself, or to do nothing, because detonation is a manual process actually, or not manual. It's forced. So the sandbox is forcing the code to be detonated, to be running. But this code, it's up to the code to do something or not, right? So another problem is that it cannot be too fast or too quick, because what is the easiest way to evade sandbox is to not do anything for 10 minutes, right? So you can detonate a file, but if this file is programmed that is not going to do anything in 10 minutes, just after 10 minutes it will start doing some stuff, then most sandboxes will fail, because they are not keeping the sample long enough to see some behavior, right? I have a colleague in another vendor that is um, producing the sandboxes, and they are really happy to announce that their sandbox can detonate a file and analyze the file in less than 1 minute. And I was having discussion with him that this is completely stupid, and I don't know why they doing this, because it doesn't make any sense, right? So yeah. So basically, the threat grid is another company that Cisco acquired back in time. It was way before acquiring SourceFire. So it's got to be something like maybe 2010, something like that. And they are quite popular, very advanced. you can have access to thread grid directly. You don't need to have thread grid access through the AMP cloud. You may have a thread grid direct access or even thread grid local machine, because there's also an option to put a thread grid local appliance in your network and use it for detonating files. So this is for people that cannot or don't want to send their files to the cloud. Okay, that's not all yet. Another thing which is quite important here is what happens if we have this position of unknown, right? So we see this file, we asked FMC to connect to the AMP cloud for this position check, and the disposition was unknown for a file. What will happen with the file? The file needs to be delivered to the destination. Okay, so we are not blocking unknown file. The only blocking is for malware. For clean is not blocking, obviously, and for unknown is not blocking as well. But what, let's say that was the 0-day polymorphic piece of code. So, and the initial disposition was unknown. So this dropper get to the endpoint, and there was an infection. Right? If we have that infected host, obviously, as I said, this is not the end of the world yet. Okay? You need to be prepared. You need to have some additional security features so you can stop this dropper from connecting to out to the CNC, right? Like security intelligence, different types, and so on. That's not the end of the world. But let's say maybe you decided to enable dynamic analysis for the file. So FTD send this file to the sandbox. But sandbox will maybe, it will take like 10 minutes or more for a sandbox. So after those 10 minutes or so, sandbox thread grid sent back the thread score, and the thread score was like 90, which is obviously the malware file. So what will happen now? AMP Cloud will take this information. The business logic layer say, oh, okay, now this malware is no longer this hash that we sent, right? It's no longer unknown, it's gonna be malware. So we changed the disposition. If we change the disposition, we need to update everybody that was asking about that. Okay? So during the next disposition check, the FMC will get an answer in addition to the answer for checked for that file that is checking on. It will get also something called a retrospection. The retrospection event, which means the disposition changed. In this case, from unknown to malware. And what we need to do with that, obviously, we will not do anything about it because the file was already sent to the endpoint. But we can cache the new disposition, and this file again will not be delivered to the endpoint. Okay, and this is the case when now a lot of people are asking me, is it worth to have AMP for endpoints and AMP for networks at the same time? And
I always say yes. In this case, exactly, it's worth to have both because this retrospection event will also reach out to the AMP4 endpoints. And AMP4 endpoints have that file still here and can take it to the quarantine. Okay? The retrospection events are very important to know of and understand that we should take care of them. Okay. And the last thing I wanted to talk here about is that this AMP cloud is a public cloud, right? So notice that from all over the world, Cisco clients are injecting all that information that they have, all that telemetry, all that samples, right? We call it collective intelligence. And this cloud is like never stopping engine. It's working all the time, day and night, right? Trying to be as as current as possible with all the different threats. That's why online solution like this is actually the future for security. And believe me or not, but this is a trend now. The security is moving to clouds, okay, for different things. That was one of the obvious. Other vendors are going, to do the same. They are building clouds because something on premises like local antivirus is no longer a solution. Where does AMP stands if compared to Zscaler? Oh God, I don't know. We would need to take a look at the Gartner or something like that. I'm not, as I said, I'm not in sales, so I don't need to worry about that. I need to know how this solution works. But from my experience, I would say AMP and the AMP cloud and the Talos and all those things that are happening at Cisco now with security are those things are huge. So I mean, I think Cisco might have the biggest threat intelligence database now, I think. Yeah, but yeah, the SIG, you mean security is internet gateway? Yes, it's yeah, actually, the whole security at Cisco is going into cloud. You can even have a cloud router now. You have a cloud proxy. You have that umbrella, right? And intelligence proxy, which is basically the intelligent proxy, which is the cloud proxy. You can now have a next generation firewall, which is not on your premises, it's in the cloud too. So yeah, a lot of things are especially in security, going to cloud because cloud allows us to be, prepared and to have always the latest information from all over the world. Yeah, ASA-V is just ASA. FTD is ASA plus firepower in the same code. Virtual equals cloud. No, because virtual, we have in the lab a virtual version. So it might be a virtual version of a firewall or virtual environment. But yeah, it doesn't mean necessarily that this is cloud. Yeah, sure. So guys, just ask questions. We can have a discussion on Slack if you wish. Some additional info about that. Yeah, use uh, that opportunity that we have here, time to spend together, and we can talk about different things. I'm open to for a discussion on that. We can do even audio session, okay, but not today, but we can do that. Sure. Maybe might be some separate thing. We'll see. Gather all your questions in one place, and then we can discuss that. Okay. So next week I will extend on that a little bit more. I want to talk about the different deployments that you may have, AMP, uh, thread grid, and AMP private cloud, public cloud, all that stuff. So we need to discuss these. I will show you the AMP configuration on the FTD. I will show you the thread grid, how it looks like, and so a little bit more around those topics. And then for next week, we have the IPS, a big, huge topic for IPS. Yeah. Okay, guys. So I think this is it for today. Yeah. Thank you very much for being with me. I hope that was informative for you. Right? As you can see, I try to go quite deep into those things because some of you might be really interested in getting some additional knowledge about some specific things. I'm always trying to give you some, the latest information about everything. So thank you very much, and yeah, have a great rest of the weekend, and see you next week. Thank you. Bye.